Hello.
Sir, good evening, sir.
Good evening. Good evening, sir. So, sir, can we start or waiting for someone to join?
We will wait for 1 or 2 minutes, sir. More people are joining, sir.
It's okay. It's okay. I'll yeah. Once all are joined, just inform me. I will start.
A very good evening, all of you, all the participants. Welcome to the second day of our faculty development program on wireless communication using 5G and 6G. Today we'll have two sessions. The first session, Mr. Chiranjeevi will be there. He will be sharing some knowledge and experiences with us. Mr. Chiranjeevi has completed his BTech and MTech from JNTU Hyderabad and has done PhD from Osmania University on wireless communication. He is now presently working as technical manager in 5G Technology Private Limited. Earlier, he has worked as technical manager in Santria for 3 years and has worked as lead engineer, software engineer in Transceiver Service Private Limited for 4 years. He has also worked as radio frequency engineer in Aster Private Limited. So I will request Mr. Chiranjeevi sir to please start the session.
Yeah. Thank you, sir. Thank you. A small correction. I didn't complete it. It's a PhD.
Okay,
Right. I
pursuing
am
PhD.
doing.
Okay, sir.
Apart from that,
Mhm.
thank you, sir. Thank you so much for introduction.
Mhm.
So let me go through my company profile for a minute. So what exactly we are doing? Just a minute. Sir, I'm unable to share. Please give me access.
You are not a co-host. 1 second, sir. Okay, you are meeting host now.
So how to use this? Actually, I'm very new to this Google Meet. I think we can. Right. Okay.
Yes, sir. Now it's coming.
Okay. Thank you. So, is my screen visible?
Yes, sir.
My voice is
Audible,
clear?
clearly audible, sir.
Oh,
Yes, sir.
thank you. Thank you, sir. So, we are 5G Tech Solutions. We started in 2019 with the intention to develop wireless equipment based on the software-defined radios. So, we started developing the wireless equipments on SDR. So, you might be knowing the SDR functionality. So, defining the defining functionality of hardware by using software. So even many of our phones are SDR based. Qualcomm and other companies are building. So that the beauty of this SDR, I did not to go for a complete hardware change when uh, application changed. For example, the same hardware I can use, same hardware means like this SDR I can use uh, as a 5G base station or 4G base station, reconfigurable device. This is a reconfigurable device. Even I can use it as a Wi-Fi router. Even I can use as a satellite ground station. So means I can use means like I can redefine the functionality of hardware. So with the help of this, and many companies are working on it, and we also started building the equipments, and we built a few equipments like a spectrum analyzer and a 4G lab setup and 5G lab setup. So that was right, and we are selling it to colleges. So that is our product. So apart from this product, we are also into staffing solutions and corporate training and training services. We do deliver multiple trainings and multiple areas, even embedded systems, automotives, as well as 5G area, as well as 5G areas. Sometimes like FDPs and workshops in engineering colleges. We are into right V2X. This is automotive connectivity, then embedded systems, right? All 5G modem development and testing courses, as well as staffing services. We do means like whenever a client requests us for the resource, we recruit either from the open market or we train the engineers and we hand over them. So these are all our areas. So apart from that, these are our products. Next signal, which is based on the SDR hardware and software. Then this is a front end radio, GNU radio based equipment, then spectrum analyzer, and next phone means this acts as a mobile in a box, so that we can see the logs and complete code. So both are network in a box and mobile in a box. So this is brief about us. So we do have a complete equipment like that. This 5G lab equipment. So we have built a 5G test bed, 5G lab setup for institutions. So it comes with these. This is a 5G test bed in a box, and these are the features of this box. I'll share this to all. You can look this, and we will provide all the experiments which are into 5G as well as 4G. So this is about our product. So when it comes to today's presentation, intelligent surfaces for MIMO. So before going that, let me go through what are all the things, means like when it comes to transmission and reception. So when it comes to, so this is the base station. So mobiles as well as this base station connects to other base stations. So this base station connects to the mobiles to transmit and receive, as well as these, right? You might be seen like white antennas like this. These are called coverage antennas. So which provides the coverage. There are multiple coverage concepts. Then another type of antennas we do see, round antennas. We call these are microwave antennas. We can see on the towers. So this is also base station. So there will be a microwave antennas. So data transportation is required between the base stations either through microwave link or fiber. If there is no round antennas, then there will be definitely a optical fiber cable. Then these will be connected to, we can say, a core network somewhere in a right head like Hyderabad. For entire Telangana and Andhra, right? Airtel may have one core center here. Then they do operations and operation and maintenance configurations, everything they do from core network. So generally this, right, this setup is called a RAN. This setup is a RAN. So here the things are, we know that when transmission or reception is happening, so when this base station is transmitting, the signal spreads like this, and even signal will impinges on the ground, signal impinges on the objects like, right, trees, buildings, and buildings. Then these objects, some objects, even human body also consumes some energy from the signal, and the buildings also consumes signal, and some will be reflected, and some objects will reflect and refract, refract the signal. Then finally it reaches the receiver here. Finally it reaches the receiver. So based on the position, whether it is right, whether this signal is going through blockage, we say generally coverage block. So depending on these objects, received signal depends on the objects, whether it is a plain area, whether it is a forest area, whether it is a urban area, rural area, right? Whenever we are traveling towards we are, when we are traveling to forest area, like our battery, right, our battery gets drained so fast compared to when we are in the urban. As well as, right, we do see less signal because of this refractions and reflections, even though when there is a good coverage. So the problem is here, right? The problem is always customer, like a user, you can say, always user expects, right, expects quality of service. So when I wanted to access the YouTube, my YouTube data, my YouTube HD video or video should be seamless. I should see videos or maybe voice, whatever it is, it should be seamless. So that is the main problem. But because of all these effects, right at the receiver, we may not see a good, we may not see the good data rate or good throughput, you can say, good throughput. So this is the major problem. So in generally, there are several statistics. Okay. In generally, there are. So this is the model of intelligent surfaces. We will see later. So this is like blockage. Actually, this is a blockage. This is the blockage. Right. So system works like this. So when base station is transmitted, so this is the mobile and this is the base station. When base station transmits, this mobile receives the power in terms of, you can say, in terms of dBs, right? We say we measure in terms of SNR or SINR. So SINR is directly or throughput, or you can say data rate, depends on the SINR or SNR. Generally, we call it as SINR, signal to interference plus noise ratio. Right? Whenever SNR is high, automatically throughput will go up. Whenever the SINR is high, throughput will be high, data rate will be high. So this mobile reports back, right? What is its status, means what is the signal strength at the mobile. So this is done through the channel quality report, which means mobiles always estimates the channel estimates the channel, then reports back. Then adaptively, this adjusts the parameters. So for example, initially the data, let us take the data has transmitted through the 16 QAM modulation or 16 QAM modulation. Then when it is received, right, SINR, dip in SINR is seen. Then it reports the bad channel estimation. Then what this base station do? Instead of using 16 QAM for the next transmission, it will reduce it to QPSK transmission, means 2 bits per symbol. This is 4 bits per symbol, means simply I can say data rate reduces further. It reduces, increases, reduces, increases. So this is happening. So there are several techniques. So you can see it look like this. Okay. So based on the block error rate, CQI is decided. Based on the CQI, modulation and coding scheme will be decided. So to improve, there are multiple techniques. So this is a model of one kind of model, you can see. So here it is transmitter transmitting. So this is transmitting block. Here it is the receiving block. So transmitter transmits, right? Here receiver estimates the channel quality, then reports several parameters. So this is PMI, pre-code matrix index, and CQI. This is the CQI and this is the rank index. So based on these values, transmitter can, right, increase the data rate or decrease the data rate. So if these are better values, increases the transmission data, is like transmission. Generally we say TB size, transport block size, means size of the packet, size of the packet, right? If these parameters are good, this transmitter packs the more and more bits in a packet and it will transmit, so that your data rate goes up. When these are bad, when these parameters are bad, pre-coding matrix index, CQI or RI, when these are bad, right, so this transmitter, right, makes the packet smaller, so that automatically here,
Excuse me, sir.
yeah.
Sir, can you please put the screen in full screen mode, sir?
Oh,
The
sorry.
diagram, sir.
Okay.
Thank you, sir.
Yeah. Just so for writing, yeah. Is this okay, madam? Seems not a big. Okay. Is this okay, madam?
Yes, sir. Yes,
Okay,
okay, sir.
thank you. Right. So here it is. Means like receiver reports. Of course, this is downlink case. This is a downlink case. Means like base station transmission to the mobile, base station to mobile. It is a downlink. Mobile to base station. It is a uplink. So similar thing happens in the uplink also. But when it comes to uplink, little less parameter compared to downlinks. So here I can simply say these are the expected range, expected example range. So for my SINR, so these are the SINRs. So very bad SINR. These are all bad SINR. SINR should be always positive quantity and as possible as high. So as the SINR increases, the CQI channel quality indicators, channel quality indicator. So channel quality indicator, higher value, higher value, higher value, better channel condition, better channel condition. So then this will leads to better throughput, better throughput, better throughput. So means whenever SINR is high, CQI will be high, then this will make means higher data. So this is my generally power level in 4G, 5G, and 6G measured in terms of RSRP. RSRP is the received reference signal received power, reference signal received power. We can see, and the range is minus 40 dB to right minus 140 dB is the estimated. Then these are several parameters. So for minus, this is lowest signal, and this is considered as a highest power level or highest signal level, you can say. So then the quality, right? Quality as well as this is a power level, this quality level, SINR, CINR, carrier to interference ratio, then CQI and MCS. And we can see for bad power level, lowest power level, we can see there is no CQI. Means CQI is a zero. Channel conditions are very bad.
Sir, excuse me, please. Chiranjeevi sir, please
Yeah,
switch
yeah.
on your camera, sir. Good evening, sir.
Madam, I am in my home. Okay, fine, fine.
What it is we want. No problem, sir.
Okay, okay. Let me. How can I do this? Give me a minute. I will.
Okay, sir, no problem, sir.
So I am unable to get out of this end slides. Actually, this platform I am not good in this Google. We have a Zoom platform, madam. Paid Zoom.
Okay, okay.
I am unable to get out of this. Even I am doing escape. I think nothing is working. Just ma'am, I'm unable to get out of this, madam. Wait to keep link your link annotation. Oh, madam. Okay. Now I can show my face. Okay. Uh,
Yeah,
I don't
yes, sir.
think that you will see my face that side. Is my screen visible, madam?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Yeah. So here it is. My pen is not writing. Just a minute. Yeah, sorry, I'm unable to write. Okay, let me proceed without writing. This platform is something wrong. Is my screen visible, madam?
Yes, sir.
So I think I am not able to write. Okay. Mm. So here it is RSRP, reference signal received power. The range is minus 140 dB to 40 dB dBm. Then RSRQ, this is a quality. This refers quality. Then SINR, CINR, CQI, MCS. For this power level, here it is the channel quality indicator. So for this power level, different power levels, I can say here it is the channel quality indicator. So for example, for minus 140 dB, right? So channel quality is 0. Then modulation will also 0. So there is, it's like it's a 0 signal. So there is no such a transmission. Then when it comes around 95 dBm, then you can see here it is SINR is 7 dB. This is very low. Then CQI is somewhere value 6-7, medium value, I can say 64 QAM. So 4 bits per symbol will be transmitted. Then MCS, here it is, MCS is a 16 QAM. Then when signal level is minus 80 dB, right, here it is SINR is 17 dB. Then CQI is somewhere around 10, 11. So which means 64 QAM. Yes. So the power level is good, channel quality is good, right? The data rate, pumping data rate is also good. So we can say minus 40 is very strong. So I can say here it is 25 dB, CQI is 15, maximum value. Then modulation and coding is a maximum value. So which means always receiver always expects the a better signal. So means like a user, as a user, when I'm accessing the YouTube, I always expects the better signal. So always network could try to satisfies the user through the quality of service. If somebody means like if anyone is not satisfied with a particular network, they will leave. So that's why there are multiple techniques to increase this power level directly, means SINR. All the techniques, whatever we see, either it is a MIMO technique or whether it is a intelligent surfaces or whatever the techniques. So these are all to improve the SINR. So how this reflects, and we can see for these CQI values, and these are the modulation, and you can see the throughput. These are the throughput values. So simply I can say for channel quality, low channel quality, low values, you can see QPSK 2 bits per symbol will be pumped. Then for medium values, you can see 7, 8, 9, 16 means 4 bits per symbol. Then you can see here the data rate as well as coding rate, channel coding rate, and this is the information bits per symbol, and you can say spectral efficiency. These are this spectral efficiency. As the channel coding means like as the channel quality indicator increases, throughput will be increases. So any system either in 4G, 5G, 6G tries to increase the modulation as well as channel quality so that data rate will be increases. So these are all techniques. These are all techniques to improve the SINR. So this is a CISO, a 1x1 antenna. So one transmitter, one receiver. So here it is SIMO, single input, multi output, single input and multi output. So transmitter. So this is I can say in some other terms receiver diversity. So receiver diversity works means same data will be transmitted in same data will be transmitter only one, but the receiver receives same data in two different paths, which will provides the redundancy. Means like for example, here it is some object, some maybe building or trees are there. Then if this path is obstructed, data can be received from this path. If this path is obstructed, data can be received this path. So receiver receives same data through different antennas. So there is a receiver combining techniques, right? This the better one is taken. So this is MISO, which is called multi-input and single output. Here it is multiple transmitters, single output. So these two transmitters transmits the same data. It is not a different data. So same data, but there is a cyclic we say delay diversity. This is generally cyclic diversity. So that same data travels through different distances. For example, we are traveling from one place A to place B. If there is only one road, if it is blocked, we cannot go, we cannot reach other end, means A to B. If there are multiple routes, right? If I can reach B through different routes, one path is from direct, then indirect, some other paths, then definitely if this is blocked, right, data reaches like this. If this is blocked, data reaches this like this. Then if this blocks, data reaches this. So the combination of SIMO and MISO, we call it is a MIMO 2x2. Of course, massive MIMO, more number of, there is a 2x2 MIMO, 4x4 MIMO, 8x even. All right, companies have tested even 25, 24, 25 antennas also. So the beauty of this MIMO, for every increase in one antenna, data will be doubled. So simply I can say, when it compared to SISO to MIMO, when this path is blocked, when because of some building here, if the signal is attenuated, then nothing will be there here. So nothing will be there. But here you can see, multiple. So this transmitter transmits, this receiver and this receiver, RX0 and RX1 receives. When TX1 is transmits, RX0 and RX1 receives. Means if one path is blocked, right, data will be transmitted through other path. So that is the behind this MIMO. So another techniques layered, right, multi-user MIMO with a layer, means like creating a virtual layers and transmitting these virtual transmissions to multiple mobiles can increase the network throughput. And this is SU MIMO. Assigning all layers to a single mobile can increase the mobile throughput. So in this case, mobile throughput will be increased. Here, network throughput will be increased. So here, right, both. If it is a uplink and downlink, uplink means base station throughput will be increases. Where of course there is no calculation of throughput calculation at the base station. Always it is done at the mobile. Either this can be a mobile or this can be a mobile. So this is the means like all the techniques to improve the SIL. So this is layer technology, means like a multiple beams. So this is a single beam from the antenna, which we say layer one. So that when data is transmitted, it is like a single road, and it is like a multiple roads. It is like a multiple roads, and it is a single road. So when layer one only used and rank one only used, right, lower SINR. If something is right, some object is there here, then the signal will be blocked. So when it comes to multiple layers, layer one and layer two, if I can able to create multiple layers by using the side lobes, we have a right. So this is the main lobe, and these are side lobes. These are side lobes and main lobe. Right, by pumping power through these side lobes, I can extend it as a layer. So this is a main lobe, and this is a side lobe. I am using this side lobe to transmit the data. So that is the fundamental concept in the layer. So ISINR. So this is another technique. So here it is a carrier aggregation. Carrier aggregation means mobile can communicate to more than one base station at a time. So this is also to increase the throughput. So even at a time, a mobile can connect it to 5 base stations, so that if each base station is pumping with the 20 megahertz, 5 base stations becomes 100 megahertz. So these techniques are also increases the throughput, means different techniques are using to increase the throughput. So this is another concept, beam concept, beam forming concept. So right, yeah, thank you. So this is my base station. If I can install one antenna, this works as a omnidirectional antenna. So coverage will be all sides. And if I am giving 100 megawatts power to this power is like a signal will be radiated in all directions. This 100 megawatts will be radiated into all directions, and it is look like a general bulb in our home, where it covers entire room. It is look like. right? Then little there is a directional antennas. So you can see on the towers there will be long antennas look like this. So this is a directional antenna which provide the coverage to a particular area like this. This is a particular area like. So means particular area people can only get the signal. And this is if I can give 100 megawatts to this antenna, 100 megawatts to this antenna, 100 megawatts to this antenna, this 100 megawatts will be radiated in a particular direction, but here entire means circular fashion. So I can simply say compared to SINR here, it will be low always when it compared to directional. This is a directional coverage. Directional coverage. Then definitely here high SINR you can see. Then narrower. This is like a generally we call it as a directional, but it can be called as a wider beam. So another is beam forming. So this is like a beam forming. So what beam forming is? So this is like a torchlight. This is like a torchlight. You can take the example as a torchlight. When we on the torchlight, right? Torchlight, right? uh, Light focus will be look like this, means it spreads over the space. So this is like a bulb, this is like a bulb, right? All directions, this is like a bulb, but this is a like a torchlight in a particular area. So when it comes to beam forming again, antennas multiple antennas depending on the frequency. Even 16 and 4 antennas, 16 antennas, 64 4 antennas, 8 antennas, 64 antennas, even 64 antennas, depending on the different frequencies. So there are lower band frequencies, high band frequencies. When it comes to high band frequencies, more number of antennas might be required. So this is very narrow based coverage, right? Very limited coverage beam. So then again 100 megawatts of power if I pump through this antenna, then
Excuse me.
this will be specific to particular area. Then
Sir, screen is
wherever-
not visible.
screen it not visible.
Yes, sir.
Yes, sir. Screen is not visible, sir.
Now only or
Yeah, just 2 minutes back.
okay, now
No, sir.
okay, just a minute. Hello.
Yes, sir.
Yeah. Is my screen visible?
No, sir.
Okay. Now, madam?
No, sir.
So now also?
Yes, sir. Yes, sir.
Okay. Okay. Maybe we lost in between. So this is like a beam forming. This is like a beam forming where we can see. So very narrower beam, right? Even when I transmit 100 megawatts of power. So this will be distributed in a small area, so that, right, very high SINR, very high SI SINR. So these are all, yes, these are all techniques. Whatever the techniques, whether it is a MIMO, whether it is a CA, whether it is a carrier aggregation, whether it is a beam forming technique, these are all to increase the SINR. Ultimately, SINR increases, data rate or throughput increases, either it is in the downlink or uplink. So the problem is here. The problem is here. So below means always signal propagation depends on the signal propagation depends on the frequency. So this is sub 1 gigahertz, means below 1 gigahertz. Below 1 gigahertz. So coverage is, right, in terms of kilometers. Coverage in terms of kilometers. Then 1 to 6 gigahertz in 5G, we say generally it is a FR1. The coverage is, you can see, look like this. Generally, these are GSM 3G, 1G coverage kind of thing. Whereas these are like LTE, LTE and 5G coverage. Definitely you can see this in terms of kilometers. This is also in terms of kilometer, but here it is, you can say 10 kilometers coverage, 15 kilometers coverage, right? In olden days, we used to see 120-meter tall tower, 120-meter tower, 80-meter tower, 80-meter tall tower. So by using 120-meter tall tower, I can even transmit 15 kilometers, even 25 kilometers. But other technologies like 4G, 5G, right, the coverage is very small, right, in terms of maybe 1 kilometer, 2 kilometers, even 5 kilometers, I can say, but not this much. Now as we are going towards the 5G and 6G, right, the frequency is going up 6 to 100 gigahertz, where 5G FR2 is 6 FR2 is 25 gigahertz to 52 gigahertz, which is very, very high frequency. And you can see the coverage look like this. Coverage, different. Of course, here lot of frequencies are there, so the coverage will be look like this. Smaller, very, very smaller, very, very smaller than FR2. FR2 look like this, very, very small in terms of hundreds of meters, like hundreds of meters only, even tens of meters only, like in building solutions like that. So this picture tells the same thing. So 600 megahertz means somewhere you can say 1G like. Then this is 1G like. Then 708 here the GSM starts. Then here it is 3G. You can say 3G, 4G. Then right, 20 gigahertz, 28 gigahertz means very smaller coverage, you can see. So right, one is frequency factor, one is the frequency factor loss. Free space loss depends on the frequency factor. So here it is the frequency space loss defined like this. Frequency space loss 20 log 10 plus 20 log F. So if F increases, loss increases. So we are talking about 5G and, right, especially this intelligent surfaces applications will be, right, in 6G, where higher frequencies are using, and this is the major problem. So one thing is frequency, as this it is right above 52 gigahertz, then definitely loss will be higher. Even means like high frequency, right, indirectly proportional to wavelength. So when wavelength is smaller, right, even a raindrop can swallow the signal, So that is the major problem, where we know that AM radio travels even hundreds of kilometers. So because frequency is less, wavelength is high. So when wavelength is higher than the object, it can pass through. But wavelength is lower than the object, then there is a problem of right signal completely. Objects completely swallows the signal. Okay. So this is one factor when it comes to 6G, where we need to take care of the SINR at the receiver. So these are the OFDMA. This is another technique used in the downlink, and this SCFDMA used in uplink, where multi-carrier. So this is a multi-carrier technology. Just multi-carrier technology. So multiple small. So this is a small carrier. The main benefit of this OFDMA and SAFDMA. Before that, we were having like a FDMA, TDMA, GSM, WCDMA. So these are all multiple access used before this OFDMA. The problem identified while using the GSM and CDMA, while transmitting 3G with a higher bandwidth. 3G is a 5G megahertz, one single channel. So when this 5 megahertz is transmitted from the base station, big chunk of bandwidth, right? It is seen that there is a huge drop in the data rate. So then huge drop in the data rate, because this huge band is getting into frequency selective fading, which leads to deep fades. Means frequency selective means certain portions, right? If I can say this is my band, so I can say this is the lower band and this is higher band, and here it is a mid band. So lower band, mid band, higher band. So because of frequency selective fading, so certain frequencies, maybe lower frequencies or mid frequencies or higher frequencies, get into deep fades. Whatever the data transmitted on that particular frequencies, data will be lost completely. We cannot recover it. So that's why people thought that instead of transmitting big chunk of bandwidth, right, they made it a smaller bands, bandwidths, like OFDMA. OFDMA itself is a frequency division multiple access, right, attached with the orthogonal. So for 5 megahertz of bandwidth, for 15 kilohertz of each small subcarrier, we will get almost 300 subcarriers. So the idea behind using this OFDMA is transmitting a smaller amount of data on a small bandwidth can lead a higher throughput. So instead of transmitting a 5 megahertz directly, slicing this 5 megahertz into small bandwidths of 15 kilohertz, 15 kilohertz, right, and transmitting, right. We have like one example. I'll take one example. Here, when I am transporting 100 kgs from place A to place B, 100 kgs of gold. When I'm transporting from place A to place B, if some thieves catches this gold, right, zero received at the, means like they takes away this 100 kg gold. So instead of 100 kgs at a time, if I can make it as a 1 kg box, 1 kg box, 1 kg box, when I transport this 1 kg from place A to place B, definitely I can say, even if thieves right, catch 1 or 2 boxes, even 10 boxes, right, here I'll get 90% reachability at the B. So the same principle is using in OFDMA, right? OFDMA itself, right? Pumping small data through small bandwidth instead of larger bandwidths, which was used in 3G and 2G, right? Other technologies. So that is the another thing to increase the throughput at the receiver. Throughput at the receiver can be base station or mobile. I hope you are all able to follow me, right? Sorry to ask, but
Yes,
Yes,
sir.
sir. Yes, sir.
yeah,
Yes, sir.
thank you. So now, so what are the right? So we have seen so many issues that, right? The first thing is because of reflections, and we have two types of concepts when it comes to interference. When it comes to interference, one is the
Sir, good evening. Sorry to disturb you.
yeah.
Sir,
Please go.
how can we handle the handoff and the self splitting in 5G and 6G, sir?
Okay, I'll explain.
Okay, thank you, sir.
Okay,
Thank you.
cell splitting. Okay,
And handoff condition.
okay, I'll explain.
Okay, sir.
So here it is. We have, right, when transmitter transmits something, as I was telling, right, because of the buildings, because of the trees, this is undergoing reflections, refractions, and reflections. It is going through reflections and reflections, then reaching with a fading. That is right, frequency selective fading, which leads to a deep fades. So the solution here, if I can bypass these objects, the solution, right? The solution is, right, definitely when lower frequencies are using, there is no issue. Lower frequencies can travel any distance with a little better compared to the high frequencies. Simply lower frequencies not required LOS, line of sight, but higher frequencies like gigahertz definitely required line of sight communication. So I have drawn one picture in the beginning, that there is a microwave antenna on the two towers. So here gigahertz frequency is used. So when gigahertz frequencies are used, if something, right, between these two towers, if someone erected this building, then definitely these two towers will not work. So they can't, means like they don't work. So either another the connectivity should be given to another tower like this, or they should dig and should lay a fiber. So that is the serious problem, is at gigahertz frequencies, right? LOS is required, line of sight is required, but lower frequency line of sight is not required. So that's why there is a concept called WiMAX. So WiMAX works at the gigahertz frequencies. So because of the nature of this LOS, most of the times this required LOS. So that's why this was not popular as LTE or 5G. So here it is, right? Here it is. Somehow we need to, with higher frequencies, we need to provide the clear line of sight between the transmitter and receiver. Otherwise, right, there will be a huge losses. For example, this fellow is transmitting 1 lakh from his account to his friend account. Let us take example. So by using GPay or PhonePe is transferring 1 lakh. When he is transferring 1 lakh, if there is a huge loss, then amount might be deducted it. Because of data loss, amount might have deducted from his account, but not credited. Means gone somewhere because of the right signal loss. Signal loss means data loss only. So then such a kind of, because right, everyone using Google Pay and Phone Pay, so that the means this kind of situation should not arise in the future. So that's why we are going for the intelligent surfaces. It is all about increasing the SINR. So whatever we have seen several techniques. We have seen MIMO, we have seen MIMO, MU MIMO, SU MIMO, then layers, CA. These are all along with the omnidirectional antenna and beamforming. So these are all different techniques to improve the SINR at the receiver. So intelligent surfaces and how this uses, right? Interference suppress. So one concept is there, right? Interference can be used. Interference can be useful in sometimes. So this is destructive interference, and constructive interference. Constructive interference means adds signal up, signal goes up, means like the interference, when interference adds positively, so this is like a positive quantity. So when interference adds up, right, our receiver signal will be boosted up. So this will be helpful. So destructive interference, when signal interference when interference negatively added to the signal, then signal level goes down. So managing this, whatever we are talking about, intelligent surfaces can bypass, right, this destructive interference, then enhanced wireless propagation. Definitely, if we take a FM radio definitely might have a specific range. You can say maybe 50 kilometers or 60 kilometers. Then LTE or 5G definitely have particular range. I cannot provide the coverage. Unfortunately, when I install one, companies installed one tower, unfortunately, right, private people might have, right, built a big building here. Then people are there here, means like you can say bus stand or a railway station, or some means like the I can say crowd, and people who are there here wants always, right, data, right. When this base station is not able to provide data here, then definitely the operator, maybe Geo or Airtel, those will right, get into losses. Definitely always there will be a, means operators also provides the coverage and quality based on the revenue. If from one base station, if revenue is coming, if revenue is more, then people will take care of that base station, right? So because of this building, then, right, these people are unable to access the network because of higher frequencies, then there is a need to bypass this blockage to provide the, right, higher coverage. So this intelligent surfaces will help here. So then extended coverage, right, full duplex, then right here it is duplex, means both way communication, I can say. So how this works, actually, how this works. So here it is a blockage, signal blockage, you can see here it is a signal blockage. Then by putting intelligent surfaces here, intelligent surfaces which can reflect, right, objects. So even human body also, when signal impinges on the human body, some signal, body absorbs some signal and it reflects the some signal. So depending on the surface coefficient, means like body or walls, there will be always a coefficient, reflection coefficient. Based on the reflection coefficient, right, based on the reflection coefficient only, based on this reflection coefficient only, signal reflects, whether it may be faster little or it may be like for example, when I compare to human body or any glass kind of surface, then definitely human body will have the lower reflection coefficient than other bodies like tables and others will have the generally higher coefficient, then signal reflection will be little high. So which is very similar concept, right? Intelligent surfaces. So when blockage is there, but my mobile is here, some mobile or some tab access user is there, then so when there is a blockage, then signal can go like this, signal can go like this. So right, so this is means like sometimes there is another concept called repeaters. So here it is my base station, then this base station transmits the signal to repeater to extend the coverage. So then this repeater re-radiates the signal to enhance the coverage. So the similar concept here, using almost similar, but here it is the base station which provides the there is a concept called heterogeneous networks which will help the means small base stations which receives the signal and retransmit like fiber repeaters like technology. So this is almost similar, where if I am seeing, right, when base station is planned like this, when base station planned like this, right, transmitting the signal, so my signal is going up to this here on, but here several customers are there. So how this operator knows that? How this operator knows that there is no coverage? There are some drive test engineers. So there are some drive test and optimization engineers. What they do, their regular job is to see the signal coverage, right? Whether the coverage is there here or here or here till here. So if they cannot, if the engineers found that there is no coverage here, and there is no possibility to pump more and more power, right? When base station pumps the more and more power, that will interfere with the other base stations, that will interfere with the other users. So multiple complications are there, multiple complications, right? Blindly base stations cannot increase the power. Blindly base stations cannot increase the power, so that will interfere with the other base stations, and we do see crosstalk, right? We might have seen crosstalk. So that's why, right, to enhance the coverage here, right, by keeping intelligent surfaces like this, intelligent surfaces, when the signals are impinges on these surfaces reflect the signal, can provide the coverage. So means like cell edge means the cell edge user means this fellow is almost out of coverage. This fellow is almost out of coverage. So this is a solution to cell edge coverage and coverage enhancement for the blocked coverage blocks. And there are coverage holes. Generally, we say these are coverage holes. Coverage holes. So right helps to there is no till now there is no concept to cover the coverage holes. So for example, if I am traveling from my home to right office somewhere here, sometimes I may enter into coverage hole. Means like even though some base stations are around it, but no base station covers, no base station covers signal this place. So whoever enters here, call will be disconnected. Whoever enters into that coverage hole, right? If I say this is the coverage hole, right? Whenever I entered here, definitely call lost, right? If it is a voice call or data call, then that will be dropped. So to increase this to provide the coverage for the coverage holes, right? Again, this can be used. So these are intelligent surfaces through which we can reconfigure. So two concepts are there. One is a passive reflector, passive and active. So passive and active. So passive means just right, there is no circuitry to given, just surface is created to reflect the signal, to reflect the signal to reflect the signal. Just so when signal impinges on this surface, it will reflect and direct it to right a particular place where mobiles can get the coverage. But here, right, again, there is no special technique to increase the coverage. There will be again a coverage limitation. I can provide coverage to up to some mobiles only, but not in a larger, and I cannot increase SINR beyond certain level. But when it comes to active, reconfigurable, reconfigurable. So always signal propagation depends on the terrain condition, means that particular area conditions. We cannot say always the same probability of signal. We cannot expect, because right, random signal, random in nature, it can go anyways, it can go anyways. So a person sitting here may see different signal levels at different times. Today I may see good, tomorrow I may see not. Today I may see the good signal, tomorrow I may not see the good signal. It depends on completely right environment. Even a small change in the position can small, even in centimeters change, even in centimeters or meters change can right decrease or increase the SINR drastically. Right? Sometimes when we keep mobile on the table, we may not see the signal. No, no signal or low signal. But when we keep this mobile inside the table, means like drawer or somewhere, we may see the right good signal. We may see the good signal. So this depends on the reflection coefficients where this mobile is placed on the table. Inside maybe iron, you can say the walls of the table maybe with the iron. So definitely iron or steel reflection coefficients are better, so that this all can be here destructive right reflections may be added in destructive manner. Here it is constructive manner. Possibilities are there, means like signal can uh, go in any way, either destructive or constructive. Even in change of, means 100 centimeters, or in change of uh, small displacement. So to tackle this, right, they introduced, means like a active, where this through this I can write more. I can time to time I can uh, I can vary the amplitude of this reflection signal. Amplitude, I can change the amplitude as well as phase every time whenever I want. Means it is a tunable, right? Active reconfigurable intelligent surfaces. Means like today, if I see higher, right, as I was telling, this interference or reflected signal can right go any way. Either it can go destructive manner or it can go constructive manner. So depending on, it is like a feedback. So depending on the coverage here, I may increase the amplitude. I may increase the amplitude today. I may decrease the amplitude tomorrow. So these kind of right surfaces, active surfaces, passive surface, we cannot do anything. Just signal is impinged. When signal impinges on the this surface, right, it will reflect, but uh, not in our wish. I hope you are able to follow me, right?
Yes, sir.
So there are multiple models. There are multiple intelligent reflection surfaces, reconfigurable and general. So here it is a multimodal, means two cooperative. Here it is single intelligent reflective surface. So mobile is here to enhance the coverage. Then signal will be right transmit, means like reflected. There is no particular transmission to this, but the signal, as I was telling, when base station transmits the signal from the antenna, it goes like this. It goes, it's like as the space it will extend, but when it is going like this, the intensity, signal intensity reduces like a torchlight. It will be like a torchlight, right? When I radiate a torchlight, intensity of torchlight, right, will be more here. Intensity of torchlight will be more here. As it is going like this, right, light disappears somewhere, so signal disappears somewhere. So there is no particular direct transmission here, but right, when it is transmitted, right, it look like this. It look like this, right? A signal impinges, and that will be reflected to mobile and provides the coverage. So this is another, means like, right, the blockage is even little bigger, means high blockage is there. Then by using two, the signal when it is transmitted, okay, antenna can be placed, antenna. So this is one antenna, it can be placed to two antennas, three antennas, even some places we see multiple antennas like this, multiple antennas. It depends on the, right, depends on the area where we are covering, whether it is a bus station, whether it is a railway station, means the cluster, we say generally cluster of people. Okay, so here, right, this can reflect here, then this further reflect and provides the signal. So this is two cooperative IRS plan. So then there is a distributed possibility, distributed deployment, as well as centralized intelligent surfaces, intelligent reflect surfaces, right? Small multiple is a distributed, right? Bigger and reflecting bigger one as a central. So this structure can be distributed or central. So even there is a possibility that, right, for example, this is an indoor environment. Indoor, maybe some shopping mall. Indoor environment, maybe some shopping mall need to have a coverage. So then outside base stations are there. So right, either so signal means, again, this is a two model. Here it is in this picture, two model where this base station using two IRS. This is one, and this is another one, which can provides the coverage to indoor. So indoor user and outdoor user, which I can have outdoor IRS, outdoor, right, along with the indoor IRS, intelligent reflection surfaces, so that this can, right, signal when signal impinges, right, in for example, when we focus, when we light on a glass like, then definitely this reflects, right, more reflects than this light, right, more reflections you see from the light. So this is a very similar concept, right? Focusing light on a glass, which will reflect very fast, and you can see the high intensity of that signal. So this is like, it's reflecting to cover the indoor. So, and these are the several applications. I can say these are several applications. So passive, right, passive and active. So signal reflection reflects the signal without amplification, no amplification, just IRS will reflect the signal, whereas here uh, with amplification. Always means like, I can retune today, how much amplitude I want, I can use. Tomorrow, how much amplitude I want, I can. Means this is a reconfigurable, right? Even through the configuration also, time to time we can manage. So generally these are not required any power, because we are not retuning, just keeping a intelligent surface in particular place, then that will simply reflect the signal, but it requires a power for amplification. Phase shift, generally phase shift circuit only. Right here it is phase shift as well as amplifiers. Then signal strength, this is low compared to this one. Signal strength is right, we can vary. So this is normal, complexity is low, and here it is high complex. Right, this is a cost effective. Right, I don't need to retune day to day this one, and this should be a little, this is little costly. So these are the typical applications about the IRS. So lot of mathematical expressions, means like formulas are involved here. Only wherever signal is there, right? Lot of mathematics, right? When we look into design level. So this is from my side, and I'll answer the right. One sir asked me handover. You can ask any other.
Not visible, sir.
Okay. So handoff, or you can say nowadays we are calling handover. Yeah. So simply handover need not to be a movement. So generally handover is considered. So here it is two base stations. Two base stations are covering like this, I can say. So one mobile is connected to this mobile. One mobile is connected to this. Then is right moving like this slowly. So it is all about power level change. How much power level this fellow is receiving from this. Even he can receive a signal even from 25 kilometers also. His mobile receives signal from 25 kilometers tower. So, but only the thing is power level change. So I can say this fellow's signal from this base station, it may be minus 140 dB. Right, I may see at this point maybe 90 dB he might be getting from the this cell or base station. From this base station he might be getting around minus 115 dB. So then always comparable, always mobiles compares right power level from different cells or different base stations, and moves based on the evaluations. So for example, so I am taking serving, and this is neighbor, this is another neighbor cell, this is neighbor 1 and neighbor 2. So always power RSRP of serving is greater than or less than the RSRP of neighbor. This always compared. So, and this is a connected mode procedure. Connected mode procedure means either a data should run on the mobile or voice should run on the mobile. So whenever this RSRP of serving is greater than RSRP of neighbor, okay, no handover required. No handover or handoff required. So whenever RSRP, this is RSRP is a power, is whenever serving is less than the RSRP of neighbor is greater than handoff required. So during the handoff, right, these two also talks, these two base stations also talks each other, that this base station tells this base station, means serving base station tells the neighbor that, hey, this fellow is coming towards, can you please take? And this replies, this if this says okay, I am okay to take, then this will hand over. So means like this base station handing over the call to this neighbor, if and only if the neighbor accepts. If neighbor not accepts, then call drop takes place. So this is about the handoff. Sir, got it?
Sir, I have a question.
Yeah, please go.
Sir, I'm Paulash. My question is, can you tell me some street scenario, street even concrete scenario for the outdoor communication, where the millimeter wave and also along with the reach are highly required.
So again, there is a
Concrete
depends.
scenario, sir, without reach.
Yes, right. There is a possibility, but the losses will be more. Wave always required, wave always expected is, wave always expected is LOS. Okay, so even this can be used, but in non-LOS, right, data rate either drops or right even zero. So most of the times, right, the application will be LOS. So when it comes to the streets and all, right, the lot of you can say non-LOS situations. So most of the times not useful for general coverage. So in 5G we have two types, FR1 and FR2. FR1 is right 1 to 6 gigahertz. So this is general public. It's like it is NOL, non-LOS communication. So this is used for general public, and this is right, especially FR2, right, beyond you can say 52 gigahertz. Then this is especially using for industrial purpose, industrial kind of thing. But of course, this can also use, but higher data rate if and only if there is a LOS, clear LOS. Otherwise, it look like a normal technology. Hello. Does anyone have any questions?
Yes, sir.
Yeah, please
Sir,
go ahead.
yes. Sir, can we call this IRS as a collection of number of transmitting antennas?
No, it is not a number of transmitting antennas. So I don't have a place. Okay. So the basic fundamental concept of IRS reflecting. So direct to transmission means, so you are telling that number of antennas. Number of antennas means by installing more antennas, I can increase the SINR here by right giving a diversified transmission paths. So this is right, we call multiple paths by creating multiple antennas, multiple antennas creates multiple paths. So this is by using multiple paths. But what is IRS? IRS is a by using a special material here. So special material, what am I using? I am mobile is here. So here is a building, because right, this mobile wants coverage, but because of a building, right, this mobile is not able to access, even though access, right, but the throughput is very low. This fellow wanted to watch the YouTube video, but YouTube video is buffering like this, buffering. Video is not loading. So definitely he will not satisfy. Right. For example, there is a big building with 10 floors, and here is a single house. Right. Single house. Right. In this single house, 10 people are there. Let us take 10 people are there. So 10 people, right, they regularly seeing a low coverage, and they are even not able to watch the YouTube, or even they are not able to open the web browser. Then definitely at some time, these people leave this network, right? These people will leave the network. So the solution is, right, when this operator wanted to provide coverage, only one solution is either he has to install the new tower to provide the coverage, either install new tower to provide the coverage either here or here. But in installing a new tower, it is very costly, because antennas and right, even it is 50 to 60 lakhs uh, costly, only the installation, erection and all. very costly. By putting a reflection surfaces like this, right? Reflection surfaces, and these are low cost surfaces, so that you can write reflected. So this is the signal reflected. So always mobile communication is a multi-path communication, which means, so there is a, whenever this base station transmits a signal, this is the mobile antenna, this is the base station antenna. So with this base station is using only one antenna, there will always be a direct path, then there will be a reflected path. Even this is a ground. Okay, so the same signal, right, impinges on the ground and reflects. So this is the direct signal. Then if there is a building, there is a tree, right, based on the surroundings, right, a signal, right, reflects from the building, signal reflects from the tree, signal reflect from the object, signal even reflect from the human beings. This is multi-path in nature. Multi-path in nature. So this multi-path I was talking about, these multi-paths can have a right, these multi-path signals may add up, that is positively add up, so that coverage means like this mobile will see a good coverage. Negatively, these reflections, these all reflections may add up negatively. So when negatively added, right, we say, right, deep fades. Signal fades away, right? One interfere with other in a negative way, deep fade. So instead of deep fade, we are using this reflection quality into a constructive interference. Constructive interference, which will help add up the reflection signal positively, so that the coverage can be enhanced. Okay, so this is a different communication, and IRS is a different. Using the property, right? IRS is using the property of reflections in a positive way. Okay, got, madam?
Yes, sir. Thank you, sir.
Yeah. Does anyone have questions?
Excuse me, sir.
Yeah.
Sir, shall we use instead of a relay, a RIS can be used so that the transmitter, receiver, antenna both can be removed, and the RIS can access a relay. Am I right, sir?
Come again, madam. Once again, repeat the question.
Oh. Sir, in a relay, that is, we are using a relay network. So instead
Relay
of
is different. Relay is different. So relay means, so here it is now the coverage is right. So people are here, some people are here, but the coverage is going till here only. So relay base stations, what they do, they receive the signal from here, right, amplifies the signal and transmits. So this is also a kind of base station, you can say, but this is not, means like receives, retransmits to other end. That is relay.
active RIS shall we use for that, sir? Active RIS.
Active risk somewhat. But this look like a complete base station. Yeah, active, we can call it as active, right? Somewhat you can say, not exactly relay, but you can think of it.
Okay, sir.
Approximately. Because relays will provide the coverage through a proper signal. This IRS reflecting straightforward.
Sir, my doubt is,
Mhm.
can we use this reflecting surface both to change the azimuth and elevation angles, like in 3D beamforming?
We can use, it is all right, angle change only, right?
Yeah, we can actually it will be only change along the azimuth,
Yes.
but we can change along the elevation also.
We can do that. So that's why active, only active, not with the passive. With active, reconfigurable active IRS, we can do.
Okay, sir. Thank you.
But you are talking about interference, right?
Hmm.
What about diffraction in this case? Is there any article related to diffraction?
These
With
are all
IRS?
diffractions, especially this belongs to reflection. Diffraction diverted, no? Just diverted.
Yes, so that that can be used to analyze the near large buildings, right? Can it be applied? Is there any article related to that topic?
I didn't see, madam.
Okay, sir. Thank you.
Dear participant, any other question? Any other queries? Sir is waiting.
Dear participants, any queries?
So we do
Okay.
conduct regular programs. If my number is added into the group, sometimes we do conduct free training programs on 5G
Okay.
and even
Okay.
upcoming 6G also. Completely, our means like we do conduct a free programs, complete protocol level, means little high level. We are also
That
planning
means
for a research, means a 5G system design program. So where a complete 5G design means not only theoretically, and we will teach you how can you build complete 5G system using SDRs. We are planning for that, especially for faculty, like faculty development. So completely streamlined concepts from A to Z.
yes,
So
sir.
those who
Chiranjeevi
are
sir,
doing research, then it will be very helpful to them.
yes.
Yeah.
Chiranjeevi sir, we want one session, sir, practical session, sir.
Madam,
We want one practical session, sir.
when, madam?
The next month we'll make a
Online or offline?
offline only in college campus. I'm planning.
In college, madam?
Yeah, college, sir.
College means equipment is a little bulk. We'll plan, but right, moving complete equipment to college.
Because in the curriculum, one wireless communication lab is there.
Okay.
So for that, I want to conduct one.
Sure, madam. Sure. I'll bring equipment. Okay.
Thank you.
It is a value-added course.
Yes.
Yeah. Recently, Welltech, they called me
Okay.
for 3 days sessions.
Okay.
Recently, done in Welltech University.
Okay, thank you, Mr. Chiranjeevi sir. I would like to express our sincere thanks to our speaker for delivering such an insightful presentation on intelligent reflecting surface for MIMO application. Sir, your deep knowledge and engaging delivery has inspired us all and sparked some curiosity to explore this subject further. On the behalf of ECE Department, Samskruti College of Engineering and Technology, I would like to extend our heartfelt thanks to our speaker, Mr. Chiranjeevi sir, to take time out of his busy schedule and sharing his knowledge and experience with us. Thank you, sir. Thank you very much.
Thank you, sir. Thank you so much. Thank you all for participating. Thank you.
Thank you, sir.
Thank you, madam, for giving me opportunity.
Yeah. Thank you, sir.
Okay. Thank you.
Now, for participants, we will move to our second session of today, okay, which will be
sorry. Means like, should I? How can I leave or? Sir, please make me as a.
Okay, sir. We will do, sir.
So that I can leave the meeting.
We will do.
Anup sir, do it.
Ma'am. 1 second, sir. It's done, sir. Hello. Hello. Am I audible?
Yes.
Ma'am,
Yes. Yes. Audible.
So we will start our second session for today, which will be delivered by Mr. S. Vivek, who is SD in BSNL Hyderabad. He has done BTech and MTech from JNTU Hyderabad and completed MBA from IIM Indore. He is currently working as a SDE in BSNL Hyderabad. He has approximately 20 plus years of field experience in BSNL, including training centers. He has some specialization in wireless communication, 4G, 5G, 6G, Internet of Things, telecommunication network, artificial intelligence, machine learning, and deep learning, and computer vision. He has delivered several lectures and talks for various organizations like Indian Railways, BBNL, RailTel, NITTR, NMDC, and universities like HCU, MANU, SRM, VIT, Manipal, Geetam, KLU, in several IT companies also like Verizon, Cyient, TCS, etc. And some engineering college like CBIT, VNR, Vardhaman, Bokaraju, MGIT, etc. Uh, Sir Vivek, Sir Vivek has guided more than 4,500 students for the internship and project from 2019 to 20. He has also received official appreciation for 3 years from 2019 to 20 for his best performance. I will request Mr. S. Vivek to please start the session, sir.
Thank you, sir, for the introduction. Am I audible, sir?
Your voice is getting somewhat disturbed, sir. Your voice is not clear, sir.
How is the voice, madam, now?
Hello?
Yeah, hello.
Yeah, okay.
My voice is...
Hello?
Yeah, madam.
Yeah,
One issue, madam. Am I clear, madam?
yeah, yes, sir, yes, sir.
Yeah, okay.
Yes, sir, your voice is clear. You can stop
Yeah.
now.
Can you share the screen, madam?
Yeah.
Yes, sir.
So good evening, all of you. I'm Vivek, working in BSNL Hyderabad. So this is the today's agenda. The topic is wave communication. In this topic, we will discuss about the introduction of the wave communication. We'll see various wave bands that are possible in 5G, 6G communication. We'll also see what are the features, advantages, and applications. And we also look after the use cases and challenges, future, and also some case studies. It's a brief agenda. Coming to the wave communication. Basically, what is wave communication? Is wave stands for millimeter wave, and the frequency range which falls between 30 giga and 300 giga are called as wave communication. So basically, these wave communication uses very high frequency, which are not used by typical normal cellular technologies which are in their place. Maybe the 2G communication or 3G or 4G. We are using sub 6 gigahertz frequencies, but what is the difference in mm wave is it is using 30 to 300 gigahertz frequencies. So the main purpose for it is you can see in the screen. So the basic idea of mm wave is to using 5G only. Mm wave communication is supported by 5G under FR2 frequency range 2. So 5G mobile communication supports mm wave, and the purpose is the higher the frequency, you will be having higher the data rates, and of course the lower latency also. So mm wave basically you can see sub 6 gigahertz can also be used in 4G and also in 5G. The only specialty of mm wave is from 5G 6G it will be there. And why specifically it's called mm wave? I think many of you are aware because of usage of short wavelengths. That is, if you convert 30 to 300 gigahertz, the wavelength reflects to be 1 mm to 10 mm. So since the wavelength falls in the range of 1 mm to 10 mm, so the mm wave, the spectrum is also called, the spectrum is called as mm wave. And the idea is higher the frequency is, as per the Shannon's law, you can see when you're having the more carrier frequency, the channel capacity also increases. Channel capacity is proportional to the spectrum or the carrier bandwidth which you are using for every customer. So that increases means the obviously higher transmission speeds will be there. The throughput will be higher. But of course, the con will be it is more susceptible to atmospheric absorption obstacles because last speaker was talking about the various interference things that will be happening in the radio interface between the mobile phone and the base station or the E node B or the G node B. So you will be having that disadvantage will be there. And coming to this mm wave, as I already told you, where it is applicable means mm wave comes and when we talk about mobile evolution. So in mobile evolution from 5G, the mm wave will come into picture. So 5G, the advantage is the speeds are high. The speeds they are talking about is more than gigabits per second. So every decade almost we can see the new evolution. First generation came in 80s and followed by second generation in 90s and third generation in 2000 and then fourth generation in 2010 and fifth generation from 2020. So this 5G makes use of this FR2, that is mm wave communication. What's the advantage? Just now, as I said, the capacity will be high, data transfer will be high. So the main application will be high dense urban environment. So in the dense urban environment, you will be finding the usage of mm wave. The other thing is because of this high speed, it's called as ultra broadband applications. Ultra broadband application means as of now we are seeing in 4G itself we have the speed, the advantages of high speed services. And this ultra high broadband the services like augmented reality, AR, VR, virtual reality, and also because of the high capacity, you will be having the advantage of the IoT also, that is massive machine communication. So these are the use cases which we will also see in a much more detailed way in the coming slides. And the other the thing is that because of this short wavelength, there is no advantages. The frequency use will be much more efficient. So one of the major drawback of mobile communication is the limited frequencies or limited spectrum, and that is the supply is very less, whereas the demand for the services is very, very huge. So to bridge the gap between the supply and demand, the only way that is only way forward is the frequency reuse. That's we have been doing it from to second generation, third generation, fourth generation, even if you are going to sixth generation or seventh generation, that will be the case unless Starlink satellite comes into picture. This will be the case. And what is the current status of the 5G mobile communication? If you see globally, almost it is in a nascent stage. By 2028, it may reach around 5 billion connections across the world. So the idea is just to show you that the 5G is picking up very fastly. Still, of course, the number of connections in terms of quantity, 4G is the having the large chunk across the world. It may be in the same is the case in India also. Here is the opportunities are high. And coming to the this mmWave communication and the 5G and 6G, who are behind us? These are standardization. The standardizations are done by basically the 3GPP, third generation partnership project, and also NGMN Alliance. So next generation mobile network alliance. This is the association of mobile operators, more than 200 service providers across the world. So the main objective of NGMN Alliance is to develop 5G and 6G communications using FR1 and FR2. And the other organization which I told you is the 3GPP. So 3GPP will be having that third generation partnership project. So third generation partnership project means the ETSI, European Telecom Standards Institute, or the TEC, Telecommunication Engineering Center, or the Japanese standardizing organization, or FCC of US telecommunication. So all are part of 3GPP. So all developed countries and some Chinese, they are part of this 3GPP. Third generation partnership project, they are involved in standardization of technology starting from third generation. So right now the release, so every year they will be coming up with a new release of new technologies. 3GPP currently they are under the R18, release 18, and R19 they are working out. And as we have seen, the logic behind the use of mmWave or millimeter wave, why we are, what is the basic advantage of moving towards 5G or 6G is, if you take 4G, the carrier bandwidth which is allocated for a user is maximum 20 megahertz. So that is a maximum carrier bandwidth that is available. Whereas in 3G, if you take, the carrier bandwidth is only 5 megahertz. If you take 2G, the second generation is having the carrier bandwidth of only 0.2 megahertz. So that is the lowest narrow band which we are using in 2G. So when you are moving from 2G towards 5G, the carrier bandwidth is increasing. You can see the relation here. The channel capacity as per Shanan's law is proportional to the channel bandwidth as well as the number of antennas, which last speaker also talked about, MIMO, multiple input, multiple output antennas, as well as signal quality, SINR. So our S/N ratio, or you can say carrier to interference ratio or SINR ratio. If you apply this equation in 5G, what is the major advantage? Channel capacity is improving fundamentally because of the increase in the spectrum. It is W. 4G, it is, as I told you, 20 megahertz max possible, whereas in 5G, it's around 100. You can use spectrum more than 100 megahertz. For single user, you can use 100 megahertz. That is the major advantage. So for 100 megahertz means it is almost 5 times more than 4G. That's the major advantage. And when you come to the FR2 band, we can use up to 300, 400 megahertz also in 5G. So that is the significant change when compared to the 3G and 4G. Because of mmWave, that's possible. Because 100 megahertz is also very difficult to allocate by the operators, as the spectrum available is very, very less. So since the spectrum available is less, the NGMN Alliance and 3GPP, ITU, as well as Department of Telecommunication India, they have come up with an idea of FR2 band, which is a millimeter wave band. So that helps, because FR2 band, you have more frequency available that will be used for 5G users. So what's the advantage? If you can see, this is a simple, you can see here, the spectral efficiency is increasing. When you see the comparison from second generation toward, when we are moving towards fifth generation, the spectrum efficiency, you can see the spectrum efficiency is increasing from 0.05 or 0.07 to 25 bits per second per hertz. So that is the level of spectrum efficiency when we are comparing from second generation to 5G generation. So what's the fundamental technology that's pushing up this is in 5G, we are using OFDM, orthogonal frequency division multiple access. Same technology is being is also used in the GSM or is 2G technology, it is FDMA, but a little more the refined form of FDMA, that is orthogonal frequency division multiple access. Even if you see orthogonal frequency division multiple access, even the in OFDMA, the subcarrier, whatever subcarrier you're using, the size of subcarrier is the lowest subcarrier size is 15 kilohertz. So whereas in the second generation, the carrier size is around, there only one carrier will be used, it is 200 kilohertz carrier. Whereas here the subcarrier is much narrower than the second generation one. So 15 kilohertz subcarriers, multiple 15 kilohertz subcarriers will be used. A user will be given a group of subcarriers, and that subcarriers around 12 minimum, the minimum resource that can be given to a user in 4G or 5G, because 4G also uses same OFDMA, unlike 3G and 2G. So 4G, 5G, OFDMA will be used, but the only difference is here we have much more refinement of cyclic prefix will be there. In 5G, you will be having CP OFDMA, because cyclic prefix is customized. It can be, we can have multiple CPs. You can use 15 kilohertz or 15 kilohertz subcarrier size, or 30 kilohertz subcarrier size, or you can use 60 kilohertz subcarrier size. So these are the multiple possibilities are then in the 5G. So that's the advantage. You can also see another advantage in 5G is, apart from mm wave communication, it also uses higher modulation schemes and channel bandwidth. You can see that 5G can support up to 800 kilohertz. You can see channel bandwidth in second generation is only 0.2 megahertz, 200 kilohertz. 3G 5 megahertz and 4G 20 and 104, and you can see in 5G it's around for 800 megahertz. You can use up to 800 megahertz. Starting from 100 megahertz, you can use up to 800 megahertz. And what's the reason behind this high speed is because of full scale the deployment of these two bands, that is sub 6 giga and millimeter wave band. So millimeter wave band, as I told you, that lies between 30 giga and 300 giga, but all the complete 30 giga to 300 giga is not used. It is not given to the 5G, but some band that we will see now. So you can see here the 5G bands fall into three categories. One is low bands, other one mid band, and other one is high bands. So low bands are the ones which will be used when you are having requirements of long range coverage or high coverages, whereas mid bands are the one which will be used for the requirements which are having medium coverage areas. So low bands will be used in probably rural areas as well as highway areas. Basically, low bands are suitable for highway areas or rural areas. Mid bands basically for town areas or suburban areas or outskirt areas, whereas high band will be used for the dense urban areas. So high bands are the ones which we are talking about, mm waves, which are frequency which will be using beyond 24 gigahertz frequencies.
Hello. Wait.
Hello, any doubt? Yeah. Coming to the 5G bands, coming to FR, as I told you, the sub 6 gigahertz FR1 band. As you know, these bands are defined by 3GPP, third generation partnership project, a sub 6 gigahertz or mm wave band, and sub 6 gigahertz band are the ones which will be falling under frequencies of 450 megahertz to 6 gigahertz range. And as you know, these are used by 4G and 4G plus, also 4G advanced, and that is, you can say 4G is nothing but long-term evolution, LTE and LTE advanced. When LTE advanced Pro also uses sub 6 gigahertz only. LTE advanced Pro means it is a R13, release 13 3GPP, and also which has the interoperability with the Wi-Fi, that is wireless LAN networks also. So obviously, the currently everywhere will be using this only sub 6 gigahertz one, that is called FR1, frequency range one, because we will be having fewer technical issues, because and environmental effects will be less, and the dispersion, diffraction, or the reflection issues will be relatively less when compared to the wave band. So, and of course, same sub 6 gigahertz from 2G to 4G. Even 5G also will use sub 6 gigahertz band. And coming to the FR2 band, these are the band which are exclusively used for 5G. Exclusively started using from 5G only. Even from 6G also, this plan is there. FR2 will be there, and these bands are earmarked for from 5G. And you can see wave band is frequency range 2 band, which are defined by 3GPP. They fall between 24.25 to 52.6 gigahertz. So this is the frequency band in which wave fall into and FR2 fall into as per the GPP. And any products, any 5G products or any 5G base stations or 5G G node Bs or 5G mobile phones, they should be adhering to this frequency range. And you can see here the wideband. The advantage is the wideband is possible because of this higher frequency band, millimeter wave band. So 24.2 to 652 means even if you take a small 24.2 to 25.2 also will have a 1 gigahertz band, and 1 gigahertz band means that's the biggest one, and the carrier frequency, that is W, will be very higher, and obviously if the W is higher, the channel capacity will be increased. That's the only logic that's applied for usage of wave band. And so there, of course, the disadvantage will be the other side of the coin is you will be having large attenuation because of the usage of higher frequency. Another advantage of wave band, as a large participant also were talking about MIMO. If you talk about MIMO, 5G users makes use of massive MIMO antennas. So that's the advantage. Only massive MIMO antennas are possible with the help of only wave band. So with the high advanced antenna technologies and with the massive MIMO antennas and with the help of beam steering and beam controlling with the variation of phase, or with the auto variation of the phase or the amplitude or the frequency, we can control and you can steer the beam from the G node B towards the user. Thereby the spectral efficiency is further improved, and thereby resource utilization will be further improved, and thereby you can regulate the losses to an extent. And other common question people will be asking is whether the 5G will be, the radiations will be harmful. So these are some of the myths that are there. But and when you are going for higher frequency, obviously there will be an issue, because you all day in and day out will use microwave oven, and we know how the heating happens. But if you are near to the antenna, definitely it may result in some ill effects are which are not recorded, which are not any documented till and as and dot. But as per the ICNIRP guidelines, as per the term cell guidelines, so the whatever frequencies are used by cellular mobile communication, they are used in the non-ionizing radiation, non-ionizing frequencies only. So whatever, even that you can see that even wave falls under non-ionizing. It's not coming under ionizing like X-rays or gamma rays. So that's the kind of it's not non-hazardous. Like if you go to an X-ray, it will be hazardous. But whatever you're finding, it's non-ionizing and non-hazardous per se. But if you are subjected to the radiation for a long period of time, standing before a base station, that you will be having definitely some health issues will be there. But for a user point of view, a mobile phone hardly radiates very less power. It will be radiating less than 0.8 watt or 0.5 watt. Hardly if an outdoor type of based mobile set also will not radiate more than 1 watt. So and also 5G is more greener, because 5G uses 4G or 5G uses less power, and that power also will be it will be using auto the transmitter will be off, switched off automatically, or receiver will be switched off automatically. So depending on the usage, so you will be having the auto detector will be there, depending on the traffic, depending on the usage, depending on the logical or signaling channel. The 5G functionality will be there. It's called as discontinuous transmission or discontinuous reception. We'll be calling it as DTX or DRX. So DTX, DRX, which are features which are there from in the cellular communication from second generation. They are much more refined when we are moving from second generation towards fifth generation. The discontinuous transmission of the mobile phone or discontinuous reception of the mobile phone not only significantly reduces the reduces the power consumption or improves the battery life, but also has a significant impact advantage towards the health of the user. And coming to the when of this 5G NR, 5G what is NR means new radio. As you know, LTE long-term evolution comes under fourth generation standards, and the fifth generation standard, the technology name standard name, wireless standard name is given as NR, new radio. And like India, so many countries have already established, and there's a point here is till now only few countries have started wave. Even in Indian context also, what is the challenge currently is the use cases. Use cases, or you can say killer applications should be there. Those killer applications should pull the customers, pull the users for widespread usage and widespread development of the products and widespread and R&D in that area. And you can see here the high frequency range used by Chinese, Japan, South Korea, European Union, and as well as USA also. And these waves, which are used by already deployed commercially by the various countries, they are basically for the ultra speed broadband only, ultra broadband. So we will be calling it as ultra broadband. For high speed applications, they are being used. For VR, AR applications, they have been used. And coming to the features of this wave communication, so if you see the applications as we have already discussed, so the basic application is integral development of 5G networks, as well as wave. They are also being used in satellite. If you talk about satellite VSAT, where we are using VSAT, and we are also using DSPT communication. DSPT means digital satellite phone terminal. So they will be looking like a mobile phone only. So they, you might have heard about satellite mobile phones. So DSPT mobile phone as well as VSAT. VSAT will be looking like a DTH setup. A DTH setup, as you know, a dish antenna will be connected to a set-top box and connected to the television set. Similarly, a VSAT is a very great option that is currently available in India, which are being served by the Indian satellites. So VSAT is used by almost all the enterprise corporates, enterprise clients, or the education institutions, or the high are very important connectivities as an option to, as a backup disaster connectivity. So disaster connectivity in case of any natural disasters, in case of any interruption of the terrestrial links, so we'll be using the VSAT links. And DSPT links, which we are using in islands, or we are using in the hilly areas, we are using in the areas where we are having projects in the forest areas, and in such areas we are using DSPT connections, digital satellite phone terminals, which will be using satellite infrastructure than using terrestrial infrastructure. Whatever mmWave is having applications both in the 5G terrestrial links as well as in the satellite communication. Obviously, mmWaves are also used in automotive radar systems. So in the radar systems for flight safety, for the pilot assistance or auto driver assistance, auto driver mode in the civil aviation sector. So these mmWaves are also used. And as I told you, and the most critical factor in mmWave is the design of the antennas. So mmWave antennas are nothing but massive MIMO antennas. So massive MIMO antennas, what is the greatness is you will be having a large number of transmitters and large number of receivers in a single antenna. If you take a 4G eNode B, if you take a 4G base station which is connected to the antennas will be hardly will be using 8x8 MIMO antenna. Whereas if you take the mmWave, we'll be using a 256 by 256 antenna, or we'll be using a 512 by 512, or 1024 into 1024, or 1K into 1K. 1K massive MIMO antennas means we'll be having 1000 transmitters as well as 1000 receivers will be there. So these massive MIMO antennas with the combination of beam steering or advanced antenna techniques, if you use, so you will be having, you can use a group of antenna elements for a particular user. You can use a single antenna element for a user, or you can use a group of antenna elements for a user. Thereby, the advantage is, as you know, the MIMO offers the an advantage of spatial multiplexing. So higher the number of antennas in a massive MIMO structure, you will be having higher the advantage of spatial multiplexing. So, and also whenever the signals are someone in the last session they were asking what will be happening if there is a lot of diffraction is there, so many buildings are there, or there is a lot of total because of signal loss in the because of multipath propagation. So there will be multipath propagation in the cellular environment. Between the mobile phone and the base station, they will be having multipath propagation, and the signal gets subjected to reflection, refraction, diffraction, or or Doppler's effect, or shadowing will be there, fading will be there, attenuation. So whatever you take, so it will be having all these issues because of obstacles that like buildings will be there, vegetation, or hills, or the.
Vivek sir, sorry for the interruption. Please switch on your camera, sir. Please.
Camera, okay.
Yes, sir. Yes, sir.
Sure. Am I visible, madam?
No, sir.
Okay, so I just had an issue, I think. Actually, I was using second one. Earlier, the mic is not good, you're saying, no? My voice was not good, you're saying. So I have to use another laptop. So here I can use only, it's like I'm using an iPad, ma'am, currently. This tablet can, what it is saying is either I can share video or presentation.
Okay.
Thank you. Antenna design. So basically, the mmWaves talking about the massive MIMO antenna. So a large number of antennas. The advantage will be large number of antennas. Means there will be a lot of flexibility. More flexibility will be there to steer your beams towards the customer. So spatial multiplexing is one of the advantage of massive MIMO antennas. The one is transmit diversity. So you can have the, of course, receive diversity is the basic one. The transmit diversity means, as you know, there will be a lot of signals get subjected to all these light phenomena like diffraction, reflection, or refraction. You will be having fading of the signal, attenuation of the signal. So that can be recovered. That results in obviously the high BER. So higher BER means you will be having a poor SNR conditions. To improve the SNR conditions, so that you can have multiple transmission. You will have redundancy of the, since the more number of antenna elements are there, the same signal gets transmitted in the other antenna elements. So more redundancy will be there, means the better transmit diversity can be provided in the massive MIMO antennas when compared to the 4G antennas or 3G antennas, or even the sub 6 gigahertz 5G bands also. In sub 6 gigahertz non-MM wave bands also can't use massive MIMO. That is also an advantage. The other is, the thing is, of course, they are trying to develop new materials and designs to further improve the efficiency and reduce the cost, and that is the current challenge that is available. And as I told you already, the spectrum under the low band, less than 1 gigahertz band, currently in India, maybe the BSNL or Vodafone Idea or ATAL or Jio, all the 4 operators are currently using. Currently mid-band, mostly mid-band are using. Low band are used by only few operators, because low band are a little costlier. Low band frequencies that is available in India is 700 megahertz. 700 megahertz is available. We are also having 850 megahertz. We are also having 900 megahertz. So 700 megahertz is called as band 28. So B28 band, so which is very popular, which is very sought after, because it lower the frequency band, higher the coverage will be there. So lower the frequency band, higher the coverage, because you will be a higher the since the frequency and wavelength are inversely related. So that's the advantage. And also another disadvantage will be definitely lower the frequency. The antenna element size also will be higher. So the antenna elements or the antenna size in low band will be you'll be having large antenna sizes when compared to high frequency band. If you're using high frequency band, the antenna sizes are relatively less, of course. But currently, whatever frequency antennas which we are using are all dual band antennas or tri-band antennas, depending on the area. So that segment is called as a radio frequency planning. So we will be doing a radio frequency planning as per the coverage, requirements of that area, as per the capacity requirements of that area, and as per the quality requirements of the area. So we will be taking these 3 criteria parameters, that quality, capacity, and coverage. So basing on that, we will be using either low frequency or mid frequency or high frequency. So currently, as I told you, the low frequencies are used in rural areas, mid frequencies in suburban and town areas, and high frequencies are dense urban area. And as you see, this is the live, actually this is the real-time picture of a 5G massive MIMO antennas. So 5G massive MIMO antennas, you can see here when compared to the basic subs 6 gigahertz band or low bands, it will be having they will be little shorter and a little wider to have the occupancy of more number of antenna elements. So the higher the number of antenna elements, of course, the size of the antenna also will be higher. So as you can see, these antennas which are which will be called as massive MIMO. So they will be used for dense urban area, or you can see dense urban area where the coverage area requirement will be less than hardly 300 meters. So 300 meters, less than 300 meters, or hardly that we will be using for this 5G small cell. And that is one of the advantage will be, you will be having speeds of more than 10 gigahertz, 30 gigahertz speeds. If you are using full frequencies, like if you are using 800 megahertz carrier frequency, we can go up to 30 Gbps. We can also provide that speed, but the disadvantage will be the coverage will be very less. But if you want more coverage, if you want, if you just speeds of 1G sufficient, if the requirement is not there, then we can go for mid-band frequencies. So these are all planning. So planning will be done by doing the survey, by studying the marketing reports, by seeing the traffic reports of the customers, which by seeing the real-time reports of the customers. So these we'll be having an NMS, Network Management Center. So NMS will be there, and so because of NMS, this is possibilities there. Yeah. So Network Management Center, we can get all this data. And well, other thing is the usage of what frequency, also the low frequency or mid frequency or wave frequency, or maybe the high frequency band. That policy also can be enabled, and we will have a special network element that is we'll be having a PCRF, a network element is there, policy and function. This PC RF network element, where you can define the policies also. And also the other important requirement for this wave is the backhaul requirement. Backhaul requirement as well as front haul requirement. What is front haul and what is backhaul? Backhaul means the base stations to which these antennas are connected. These base stations are to be connected to the core network. So these 5G base stations or 4G base stations or any technology base stations, they are to be connected to the core network, because base stations are the one which will be acting like an access network, which will be acting like a bridge between user and the core. So core network is the one which will be having all the intelligence, which will be having the intelligence to connect the one user to other user, or intelligence to connect the one user to the application. I suppose you are opening a Instagram on your mobile phone, or you are opening YouTube, or you are opening a Google Meet application on your mobile phone. So this user should be connected to the Google Meet app. This user should be connected to YouTube app. So user, person to application, or application to application, or person to person communication is possible when only by the core network. Core network, we will be having that intelligence will be there. So where we will be using only the packet switching only. The packet switches which are there in the core network are to be connected to the user with the help of this the base stations, which are called as gigabit node Bs in 5G, and there this wave is used. So waves are used only as a carrier between the user and the base station. So there is no purpose of the wave between the base station and the core network. Only waves are used to carry the baseband data between the user and the base station. And this backhaul connectivity is also challenging, because when you are opening up higher speeds or higher throughputs to the user, means obviously the connectivity, the pipeline that is there between the base station and the core network also has to be enhanced. The pipeline that will be there means you will be using optical fiber cable. So optical fiber cable bandwidth also you need to plan. So optical fiber cable can have an infinite amount of bandwidth, but systems which are to be connected to support that high bandwidth are to be installed, are to be deployed, and are to be in place to support this wave communication. And as you see, what are the advantages? One of the applications are one of the use case. Some of the applications you can see the coverage solutions like 5G. As I told you, 5G wave communication. Mostly they will be very, very short range, but ultra high speed connectivity will be there. Whenever you want to go to wave, means ultra speed only it's possible. So 5G waves is, for example, on the you will be having a street light tower or a electric tower. On that electric tower, on that pole, street poles will be there. The street lighting poles or the electric poles. You will be keeping the operators are keeping a 5G base station, 5G GNB, and that will be covering almost a distance of around 200 meters to 300 meters in that colony, in that street. So street and fit, and every user, the 5G user can have, he can go for a solution like, so he can opt for a wireless broadband connectivity. So wireless broadband connectivity, which will be having more reliability when compared to other solutions. 5G offers more reliability, and the 5G G node will be on a pole, and in the house you will be having a 5G router will be there that will be deployed on a, which will be having some it's a little line of sight, may not be perfect line of sight, but may not be inside your building, but just if you have an aerial, it will be kept outside, and that will be sufficient. You will be having excellent speed, and you will be, of course, the 5G whatever router is there, or 5G the box side will be kept at the user side. They will be calling it as CPE. That CPE will have Wi-Fi connectivity, and you can have indoor connectivity also. So whatever CPs right now we are using at homes, the BSNL fiber or Act fiber or Geo fiber. So these will be having only one side wireless will be there, other side you will be having wireline connectivity. So you will be either using a LAN cable or a twisted pair cable, or you will be using a the twisted pair cable, or you'll be using the optical fiber cable. So these are the ones that's available. But if in case of 5G, both will be wireless. So both the backhaul will be wireless, and the front end, the front haul also will be wireless. So coming to the architecture, how the MM wave architecture will be there, which is coming under the 5G. So you can see the architecture is called as SBA, service-based architecture. Service-based architecture means you can say here whatever network elements are there, the core network elements, they are programmed as a function. So they are converted into a functionalities. These functionalities are nothing but the software programs. These software programs will be kept in a data center, or you can say cloud. So if you look at the service-based architecture, you can see UEs are the one user equipments. UEs are the user equipments of the 5G mobile phones, whereas GNBs are the one which are the base stations, gigabit node Bs, whereas the UPF, user plane functionality. So this is a flat architecture. If you look at the physical hardwares or physical devices in a 5G or MM wave network, you will be having only very flat architecture. You will be having the mobile devices connected to the base G node B, that is the base station, and the MM wave will be used between UE and G node B, and G node B connected to the backhaul, as I said, to the UPF, means user plane connectivity, user plane function. And this is the network. In this network, you can see only 3 core network elements are there. Physically, you will be finding UEs at the customers, GNB at the towers, cell towers are at the or on the top of a building, or you can say that any altitude or any structure where it provides a little bit coverage. So that will be there, and the UPF are the one which is the core network elements, which will be there only the physical availability will be there. And this and you can see here they are connected to the data network. Data network means the internet. So data network will be having across the country, will be having the fiber connected to every station, for every station, or it may be a dense urban area or a rural area or in a town area. So all the major exchange, you can be calling exchanges or major cities or major stations or major places. These places are connected by optical fiber, and every station will be having a router depending on the capacity requirement of that area. So if you are having a metro city, you will be having metro routers will be there. If you are having a rural area, a small router with a small number of WAN ports or LAN ports will be there. So that's a major difference. And UPF is the one which is the core network. So 5G network will be the MM wave network or 5G network will be very, very minimal, and it is a pure flat IP architecture. What about the other one? So what about the rest one? The top ones you are seeing, service-based architecture, NEF, NRF, and UDM. What are all these things? So these network elements are basically the software network elements. So whatever the top portion are there, which are connected to the UPF, SMF, AMF, AD, AUSF, what are all these things mean? These are the functionalities. Functional network elements are the software functional elements which will be programmed in the cloud. So in the data center infrastructure. So the data center infrastructure means currently for the entire South Zone, we have a data center at the centralized location. Okay, so currently the India, as per the government of India, the entire geography of India is divided into different zones: North Zone, South Zone, East Zone, and West Zone. If you take South Zone, the South Zone, you are having AP, Telangana, Karnataka, Tamil Nadu, and Kerala. All these 5 states are operated under a single data center. You can also use the for entire the country also you can have a single data center, but to have more redundancy, to have to reduce the latency to an extent, and also to improve the effectiveness. Currently, they are using zonal level of data centers. So these data centers are the one which will be having the virtualization concept, network function virtualization, software defined networking will be there. So and also service based architecture. And see, all these network elements, all these functionalities can be programmed, and they can be customized. Only thing is, you will be in a single. Suppose if you go to a data center, if you go to a cloud infrastructure, you will be finding IBM Blade servers or HP servers will be there. So these servers elements will be having several virtual machines. They will be divided into the several virtual machines. Each virtual machine will be loaded with a functionality. And if you take AUSF, what is AUSF means? Authentication service function means the AUSF functionality will be loaded with all the data of the SIM cards. So every user will be having either a physical SIM or a eSIM or a iSIM will be there. That SIM card data. So that SIM which will be sold by the operator to the user, the SIM will be having specific set of parameters like IMSI will be there. It will be having some parameters. Those parameters will be filed in the core network as well as in the SIM card. So whenever a user is making a connectivity to the network, so that user should be authenticated, it should be authorized, and it should be accounted for also. For authorization purpose, AUSF will be doing the functionality. So it will be having the database. It will be having preloaded database of all the SIM parameters, and UE will be having SIM parameters. So that UE SIM parameters will be pushed through GNB to the core network, and AUSF is the one which will be responsible for verification of that authentication parameters. So just to ensure that only genuine customers log into the user network, it may be the Jio or it may be the BSNL, it may be the Airtel, like that. And here having the AMF. And AMF, the access management function means access management function is talking about the basically it will be providing the mobility management. Mobility means so one user will be at one place right now, and after maybe 1 hour he will be moving to different location, or maybe next minute only you will be going to different place. So the user location is not a fixed one. A mobile user will be keeping on moving. So this information has to be tracked by the mobile by the core network. Service-based architecture of mmWave technology should be tracked every moment, because even though user is making a call or not, all the times the mobile phone will be receiving the notification. All the times the 5G mobile phone or 6G mobile phone will be having the always data, always always on connectivity will be there. So because of that, continuously notification should be there. So that tracking should be there. The track the user just for the purpose of providing the service. You should have AMF. AMF functionality is very important because it will be tracking the location. So location updation or LU process will be done by this AMF. And SMF is a session management function. It will be nothing but the control functionality. So the core net earlier traditionally it's called as MSC, Mobile Switching Center. that functionality is split into soft switching. The control part and user part are separated. The user part will be taken care by the user plane functionality. The actual routing, the bearer functionality, the bearer connectivity will be done by UPF, whereas the signaling function, session function, or establishment of a session, or releasing of a session, or disconnecting the session, or accounting purpose, or CDR generation, call detail record generation, or data record generations, everything will be done with the help of SMF. Similarly, the other functionalities will be there for different functions. So you can repository function will be there. User data management function will be there. You will be having policy control function will be there. As I told you, PCF. PCF is a policy control function. You can define the policies. You can define the policies so that during the night time, let us use only low band frequencies. During the daytime, use the high band frequencies. Or during the peak hours, during any, let's say, a stadium is there and there's a matches, IPL matches going on. During the time, what frequency band you need to have, you need to change the G node base to high band or MM wave bands. So likewise, you can define the policies both under the radio interface area or the core network interface area. So this is the if you see the mmWave 5G end-to-end network, the end-to-end network will be the same. Will be having different layers, and each layer, and as I told you, the core network layer is the most important one. The core network layer is intelligent one, and the core network layer you will be having the service-based architecture, as I told you. The service-based architecture advantage is it's nothing but the softwareization of the complete core network. So the network element, the network functions, can be in a one core network, in a one data center, or it can be in a multiple data centers also. So suppose I have one core network function in Gurgaon, other core network function maybe I can keep it in Chandigarh, or one core network function I can keep in Bangalore, other one in Hyderabad. And these functions, we will be calling it as VNF. These VNFs are connected through APIs. So this is the in service-based architecture. The usage of APIs will be there, application program interface. So these APIs, because that open source APIs can be used in order to have connectivity, because all functions are integrated. So just now I told AMF, access management function, AUSF I also told. So AMF and AUSF are related. Whenever the customer location is tracked by the network, it also has to authenticate. So suppose customer switches off, then switches on the phone again. So the AMF functionality, the mobility tracking location updation functionality will have. And during the time, the authentication also should happen. Authentication is not happening means the genuineness of the user is not found. Okay? And as I told you, SDN controllers will be there. SDN means software defined network controllers. So all the network elements are can be controlled by a software, and thereby reducing the number of resources. So this mmWave networks uses software defined network, and also it also uses SON networking, self-optimizing network, uses AI and ML techniques to improve the efficiency and effectiveness of the network. Coming to the use cases, some of the use cases which are very, very popular in mmWave communication are these. These are the diverse use cases that are used elsewhere. It is the EMMBB, enhanced mobile broadband, EMBB, and then MMTC, massive machine type communication, as well as URLLC, ultra reliable low latency communication. So these are the diverse applications. What is the beauty of these things are? Each and every application is completely diverse. As I told you, the PCF will be there, policy control functionality. The policy control functionality you can define what kind of users are there, what kind of applications are there, what type of resources are to be engaged. So, and if you are when mmWave should be utilized, mmWave can be utilized. Whenever customer, the users in that area are demanding, are going for EMBB service. Whenever users are going for EMBB service or augmented reality or virtual reality services, then they require high data rates or high speed data rates. Then we will be going for this wave. Suppose if the customer is going for MMTC, suppose customer is a IoT application. So IoT application, let's say you are having a electric meters are there in our home, and electric meters are fitted with this IoT. They are IoT enabled, let's say. So all the whatever meter readings are there, it will be automatically recorded. It will be sensed by the IoT device, and it will be captured by it, and also it will be uploaded to the control center. It will be uploaded to the cloud. So IoT devices or IoT users requires only low speed. It doesn't require high speeds. In that, but IoT devices normally, since they are for a large capacity, they will be having large number of users, IoT users, because we'll be using large number of sensors, a large number of devices in a particular area. So capacity is requirement will be there. So we'll be using a low frequency band, low bands, or mid band, depending on the frequency range requirements. URLLC usually will be going for it depends upon the latency requirement. Ultra reliable low latency applications. So basically, URLLC is the applications like robotic surgeries or driverless car. These are the facilities where latency requirements are there. As I just told you, MMB focuses on the speed. The downlink speeds of MMB requirement is peak speeds at 20 giga and uplink speeds at 10 giga speeds. And if you take the spectral efficiency in the downlink is 30 bps per hertz. 30 bps per hertz. The uplink, of course, uplinks are less when compared to downlink. And of course, user experience will vary. User experience, downlink and uplink again, when compared to the peak data rate, user experience will be around 100 Mbps. Mobility, it can offer when compared to the 4G, it offers and the customer speed, the customer physical speed can be more than 300 Mbps. Still, eMMB can support. So this is the major application of the mmWave. What are the other applications of mmWave, or what are the other use cases of mmWave? As I told you, these are some of the we heard about Google glasses or Google wearables or Samsung wearables, and these flexible mobile devices, Surface TV, things like that, which require a lot of virtual reality and augmented reality. So these are 3D projection or 4D projection. These requires you need a high speed in order to digitize, in order to capture all the content of the various dimensions. You need much more speed in Gbps, and 5G is the enabler. mmWave is the enabler to have that immersive experience. So immersive experience, as we have seen, this augmented reality or virtual reality. If you take the VR glasses, and you will be having 360 degrees view of the surroundings, and the picture quality will be I know, maybe 16K ultra or 4K ultra. The picture quality as well as the experience will be much better. So for that, mmWave requirement is must. And you can see here URLLC. As I told you, URLLC stands for ultra reliable low latency communication. So low latency means, what is the latency? 1 millisecond is the latency. So 1 millisecond latency means the speeds it can support up to 1 millisecond. The speeds, whatever speed that are there, the latency is the end-to-end round trip delay. The round trip delay is the most important factor for applications such as driverless car or autonomous systems will be there. No, autonomous systems like robotic surgeries, or even that is also one of the important application it has appeared in the recent times. Robotic surgery, we'll be seeing, whenever you see Tim Sunshine, or when you see the Sikara hospitals, or when you see Apollo, there ortho robotic surgeries will be there. And these robotic surgeries, if the doctor, let's say doctor is not in that area, and the doctor is at the main doctor may be in the remote area. So by using robotic surgery with low latency, because the latency should be very less there, and he can do the surgery. Doctor can, remotely also he can do the surgery. The other important application is majorly the driverless cars. So as already you've seen, more Tesla cars are already in place, and almost every state of the United States. You can see that they use it, and the driverless cars requires low latency. Whenever the cloud control center want to apply the brake, means immediately the brake should be applied, or that without to avoid the collisions or to avoid any accidents. That latency is requirement, and that is possible because of the low the smaller time slot that is being used in 5G. The 5G you will be using time slot of 1 millisecond. And coming to this, the URLC use cases, other than robotics and autonomous vehicles, even industrial automation also is required, because industrial automation, suppose you are using in big industries, manufacturing industries, interaction of different systems are required, and if latency is there, that may result in any hazards. To avoid it, it can be used, and even in the drone communication also, aviation also, the URLC application will be there. So latency is a factor here. In URLC, you don't worry about the speed. Your speeds may be moderate. The speeds may be in 10 Mbps or 20 Mbps, or less than that is sufficient. But the major requirement will be need to steer it. Maybe you have to steer the vehicle, or need to perform some command remotely. The latency is the most important factor. Whereas the capacity is important factor in IoT, whereas in latency is important factor in URLC. But mmWave specifically will be using for EMBB application. So MMTC application, also I told you the capacity requirement will be there. So device, you can see per square kilometer more than 1 lakh devices are there. So that is the kind of capacity it will offer. And the energy efficiency also is one of the important factor for MMTC application. MMTC means massive machine type. It is IoT. So IoT device should provide less power consumption. So they should have a longer period. So that is also one of the important factor for MMTC. And coming to the challenges, what are the challenges that are there in the implementation of mmWave? So some very important challenges are there, because as we already discussed that in mmWave, the wavelength is very, very narrow, between 1 mm to 10 mm. So the propagation characteristics is the issue. So it will be limiting the, because wavelength is small, obviously the coverage will be small. So that's a major challenge for operators. So the major challenge is, do you need to have more number of 5G base stations or mmWave base stations if you want to deploy it? More number of base stations means it is a huge pressure on the capital expenditure, as well as an OPEX, or operational expenditure, and that will increase expenditure to a large extent. And that's a reason why the telecom industry is a capital intensive industry, and a lot of if you take service providers, more large number of service providers which were there 5 years before, they were not present now. Like Aircel is not there, Docomo is not there, Telenor is not there, like so many BPL. So many companies were not there because they could not sustain this race, because the technology keep on changing. No, we also change the mobile phones every 2 years or 3 years. We have to change because of the technology. Similarly, here also that the issue that will be there. And the technology change is not only the changing of the equipment is not only the challenge, but also the whatever. Suppose if you take 4G, the 4G base stations, let's say to cover fully the Hyderabad. If you take a Hyderabad metro area, to completely cover the Hyderabad by 4G network, you need to know. You will be surprised to know how many 4G base stations will be there. it will be more than 8,000. Suppose 8,000 base stations are required to completely cover. Currently, 8,000 base stations are there only to cover the Hyderabad 4 network, Hyderabad 4G users. Suppose if you want to deploy 5G in full scale, if you want to deploy 5G in full scale with wave, if you want to provide EMMB service, enhanced broadband service, if you want to mobile broadband service, EMMB service, by using wave frequencies, it is in FR2 range to all the users, in that area, means in the Hyderabad area, means minimum you need to have more than 40,000 base stations per user, per operator at least 40,000. Currently, I didn't know, it is around 4x times when compared to the 4G. So that is the kind of number of base stations that are required. So that is a huge burden on the operator, and that's the reason why these waves base stations or GNBs will be deployed in locations where the requirement is there, where actual requirement is there in that server area. You need to find out the use case are to be there, and the customers are to be they should have that full requirement. They should have that if there is going for it, their subscription should be there. Then only operators will be going for it at FR2 range. That's a huge challenge is there. And other challenges that are in place are regulatory and standardization aspects are there. Regulatory bodies like FCC is the Federal Federation of Communication in US. So that TRAI, Telecom Regulatory Authority of India, Telecommunication Engineering Center, SACFA. The SACFA clearance should be there for any base station. Whenever 8,000 base stations we are having, means any base station, if you want to deploy, that SACFA clearance is required. SACFA clearance, and WPC means Wireless Planning Committee. So Wireless Planning Committee are the ones which will be which are part of DOT. These are DOT arm. And these DOT arm, they are the ones which will be allocating the frequencies to the various operators, or not only operators but also for different applications. Let's say radar communication is there, and let's say FM communication is there, or let's say TV communication is there, or OTT channels are there, or civil aviation flight communication is required, or in-flight communication is required, or any industrial applications are there. Anything, the WPC licenses will be given, and they will be earmarking the frequencies to various establishments or various applications as per the Government of India guidelines. And international standards, as I told you, 3GPP, they have to, any operator, whenever they want to deploy, it means they have to adhere to the NGM and Alliance guidelines or 3GPP guidelines, just to have interoperability. If you don't, suppose if a country is there and they don't want to follow the norms of other countries, means they will not be having interoperability will be there. They will not be having the connectivity issues will be there. Interworking functionality issues will be there. So to avoid these compatibility issues, just you have to follow the all international standards. The 3GPP standards are the ETSI, NGM, and Alliance standards, etc. So these regulations are most important for the implementation of MMWave. So other important aspect that also found recently is this, as I told you, one of the important organizations which is involved in assignment of this FR1 or FR2 bands are ITU. In India, we'll be having the WPC or SACFA or TRAI, but across the world, a governmental body, intergovernmental agency, which is overseeing the telecommunication development, the telecommunications standardization, is the ITU, International Telecommunication Union, which is a part of UNO. So the issue is here, some spectrums in 5G, which are there in the blocks. Like, see, you can see these are the various frequency carrier numbers, like 25, 40, 45, 7 watt block. These are some of the frequencies that are there, and they are some blocks are having the interference with the aviation sector. Like, see, probably you might have came across this article, or this maybe in your social media, or your mainstream media. So recent in ET Economic Times also this news has come. In US, some of the states they had interference issues with the 5G frequencies. 5G frequencies, as I told you, different frequencies are there. No, so what is the issue means the aircraft altimeter is also using the frequency range in the between 4.2 to 4.4 gigahertz, and 5G frequencies also fall in that range, and it is having interference with that. And with the 5G rollout in US, that issue has come. Same thing, that no, that issue has come in one's country means definitely the same. See, whatever flights Indigo is using, whatever flights Indian Airlines are using, all flights are whether Boeing or it may be the common aircraft will be using. So, so the ultimate will be having the rate. So what they have done is the product change has happened, because we cannot change 5G now. The frequencies are very difficult to change because already are earmarked. So some of the altimeters are wherever such altimeters are used, they should be having a communication between the civil aviation people and the 5Gs. Those frequencies are to be avoided. So they should be having a mutual consensus should be there, and they should be having a mutual policy to avoid this thing, because flight is more hazardous. No, if any issues are there with the altimeter, that cannot not be showing the proper metrics to the pilot, and it may result in accidents also. So to avoid it, they have stopped 5G for a while there, and then after there's a resolution of the issue, it is again commenced. And the other issues that are there is the security challenges. So that's MMWave security challenges are most important. Whatever security is there, they are the layer. We need to follow the layered security from L1 to L3. All the layers you need to follow. As you know, in mobile communication, when you are talking about radio interface, you'll be having only 3 layers: L1, L2, L3. L1 is a physical layer, all the data link layer to the network link layer. It will be L2, and from the transport layer to the application layer, it will be L3. So only 3 layers will be there. Every layer has to be taken to consideration while designing the security, because security effects will be more, because 5G will be will be carrying more data, much more data when compared to its predecessor technology. And when you're talking about use cases like URLLC, like robotic surgery or driverless car, or if you're talking about applications like virtual reality or or augmented reality, VR glasses. So the kind of impact the security challenges pose are it is much more severe. To counter it, the security model should be much more rigid and solid. And coming to the future, you can see one of the more challenges is the signal loss, because as we know, the limitation of the 5 mmWave is the low range. That is the most limitation. That's the biggest limitation. And currently the research is going on in the direction where the speeds should be ultra high, and also latency should be ultra low. So that is the requirement that is driving further mmWave and advancements or R&D is happening, and to overcome those things. And coming to the other case studies that are happening is you can see here the mmWave, mainly the distributing. When you are using distributing antennas, we can use much more improve the diversity or robustness of the signal can be improved, and coverage can be improved. Distributed antennas, because last speaker also somebody asked about relays and all that. So when you are using distributed antennas or things like relays and such in a much more heterogeneous environment and head net form of structure. So mmWave deployment can be much better anyway. And research initiatives are also happening in medical imaging and remote surgeries. That's what I discussed. So medical imaging also, this mmWave is coming into picture, and also smart city projects. smart cities projects where IoT applications will be there, and where high-speed data requirement will be there, and where dashboard metrics are to be displayed, MM-Wave will be into picture. So finally, as we know, this is a very transformation technology, and MM-Wave is having in the scope is there also in the 6G. Though a lot of challenges are there, as we have already shown, many countries, many developed countries already deployed it, and India is also operators Jio, BSNL, Airtel already got the licenses to operate in FR2, but they why have not started means once you start using that FR2 band means you need to start paying the license. So the only challenges that are there is the use case, the pulling factor from the user side, and that they are innovating, and even government is also trying to develop the use cases by investing in a lot of startups. Last budget also government has funded more than 100 startups to drive the innovation in the applications. Okay. Thank you, one and all. Now the session is open to queries.
Good evening, sir.
Yeah.
Sir,
Yeah.
what is the spectrum that is allocated for mobile communication nowadays, sir? It is from megahertz, gigahertz, and also in millimeter wave.
Currently, the spectrum that is used is FR2 band, madam, 24.2 gigahertz to 52.6. This is the frequency band that is there for MM wave.
Sir, 22 point?
24.2 to 52.6. That is the frequency currently that is there for for MM wave, madam, millimeter wave.
Okay, sir. And in megahertz range, sir?
That is something. So many bands are there, man. Currently, let's say, currently we are using the phone. No, what frequency bands we are using is, suppose if you are using basic 2G, let's say, we are using 900 megahertz band. Suppose if you are using a Geo connection, so Geo currently they are using a 2.5 gigahertz band. 2.5 gigahertz band is the one we are using. And suppose if you are in a rural area, the band which you are using is 700 megahertz band. So how you can remember easily means almost all the odd numbers are there. 700 is there, 900 is there, and also followed by the ISM band is the most popular one. ISM band is the Wi-Fi band, 2.1 gigahertz band. Just beside the Bluetooth or Wi-Fi band also 2.1 gigahertz band is there. And that is called as 2100 megahertz band. That is also currently used, madam. Most likely, our laptops or our mobile phones, they are using mostly 2100 or 2500 or 900. These are the three bands which you are using.
Okay, sir, this 900 megahertz band means what is the range?
Range means if you are taking 900, normally these bands, whatever all the low bands and mid bands are using FDD only, madam, frequency division duplexing. So 900 means the uplink will be 890 to 915, and downlink will be 935 to 960 megahertz. So 25 megahertz is the uplink and 25 megahertz is the downlink. So you will be having a duplex spacing of 45 megahertz, but ultimately the bandwidth is 25 megahertz.
25 megahertz.
So very good evening, sir.
Sir.
Thank you.
Yeah, thank you for a wonderful presentation. Sir, actually, what is the radiated power from the tower actually presently being used by BSNL?
Not only BSNL, if you take overall, so the power that is radiated by the base station depends upon the your coverage requirements actually. If you take dense urban area, the coverage requirement, as I told you, it will be very less, because if you use high coverage, obviously the reuse cannot be done. If you want more number of reuse, the coverage should be less. So the range is normally, if you are talking about dense urban, the power level is 10 watts only. So the base station power range starts from 10 watts, and if you go to highway area, it will be 40 watts. So 40 watts space stations are used in the highway area, because highway area let's say outer ring road area is there, or if you take the outskirts of highway area, so there you need to cover long area, no? So you'll be using 40 watt power. So 10 to 40 watt is the answer to your question.
Thank you, sir. Thank you.
Yeah. Thank you.
Sir, can I know about the type of antenna that is being presently used for radiation?
So
whether we
whatever
have been going with array antennas or we have been having any specific type?
all the antennas which you're using are array antennas. If you maybe to take 2G antennas or 3G or 4G or 5G, even the 6G, whatever antennas you're taking, all are arrays only. All are arrays, but we are using the what is the antenna? What is the dipole? The dipoles are polarized. The polarized dipoles we are using. All are you can say vertically polarized dipole array is the antennas which you are using.
Sir, what is the gain actually expected for the antenna, sir?
The gain is also again is a planning parameter, and the gain is not a fixed one. But usually, if you take a dense urban area, the gain which we'll be using as we'll be using 10 dBi, 10 dBi antenna. Or suppose if you're using a rural area, so there the more no the rural area, what will be typically the distance between the baseband unit and the antenna will be very high. You will be using large RF cable. Losses will be there. To cover it, you will be using high gain antenna. Maybe you will be using 20 dBi, or even you can use 25 dBi antenna.
Thank you, sir. Thank you. Thank you very much.
Sir, one more question, sir. Presently, are we using the what you call omnidirectional antennas or directional antennas, sir?
Yeah, both 90%, 95% are directional antennas only, madam. Only omni antennas will be using the indoor coverage. We'll be calling it as IBS. IBS is indoor building solutions, like in airports, in a big railway stations, or if you go to a cellar area, shopping malls. Inside the shopping malls, you'll be seeing on the false roof, you'll be finding the omni antennas. Omni antennas hardly will be having only less than 5 watt power. For only coverage of indoor building solution, we are using omni. Rest 95% or 97% all are directional antennas.
So are we using sectorization nowadays, sir?
Sectorization is mandatory, man, sir, because as I told you, larger the number of cells, larger the capacity. So sectorization is the must. Every base station, wherever base station is there, directional antenna purpose is only sectorization. As you know, we are using directional antenna only to sector only, because more sectors, more the number of cells. More the number of cells, more the number of reuse you can make. So to make reuse, one of the first thing what we will do is cell sectorization. Typically is 3 sectors. In the 5G also 3 sectors only. 120 degrees is the planned area, but the directional beam width will be using as 65 degrees only. Suppose if you take whatever area we are right now in Hyderabad or Bangalore, if you say that all the urban areas will be having directional antennas of 65 degrees only. But if you take a highway area, the beam width will be 33 degrees beam width will be there, because narrow the beam width, the range will be narrow and will be having higher range.
Yes, sir. So at that time, we need to have more antennas in the same cell, sir, for 33 degrees beam width.
33 beam width, normally highway only you will use, no, madam, because in the highway, the purpose is to cover only the 2 sides. Suppose if you are having a perfect highway where there is no village or no density is there on either side of the road, only the traffic is there on the road, let's say. Then typically we will be using only 2 antennas, only 2 sectors will be there.
Sir, in the textbooks, we generally read that about cell overlay and underlay. Is those techniques are used now?
Yeah, yes, ma'am. We will be using overlay and underlay, and that these last speaker also talked about HETnet, heterogeneous network. These this is called as HETnet. These heterogeneous networks are coming to picture, this overlay and underlay more in 5G. Why? Because the 5G, the spectrum should be to improve the spectrum efficiency. These techniques are used, madam.
So where do we use the underlay and overlay, and where do we use sectorization?
For example, just I will give you a small use case. My example, let's take outer ring road is there, madam. ORR, let's say near Gachipoli, ORR is there. In Gachipoli, maybe it's outer ring road, but towards Shamshabad, you'll be having some no low density will be there. But if towards Gachipoli, if you take a lot of density will be there either side of the road. Okay, let's take a customer is going on an expressway and outer ring roadway, he will be more faster, no? If for a fast moving customer, you will be having the there will be requirement, more handoffs are required, more handovers will be there. So for a handover customers, the overlay will be there. Let's say for a customer is there, let's say he has the restaurant is there, or maybe the customer has parked the car, or maybe customer has went to restaurant, or customer went to some any park, etc., or he exited to an IT building there. Then let's say he want more speed. Then your underlay vision will be there. So depending on the requirement, that flexibility will be there, madam. That adjustment will be there, and that should be dynamic.
Okay, sir. Then, sir, what about handoffs, sir? Soft handoffs or hard handoffs nowadays?
Both, but see, in 5G, you will be having only hard handoffs because it's OFDM, break before make only. So all hard handover, whenever you're using FDM means only this one is only hard handovers only. Soft handover only used in 3G. Soft handover only in WCDMA. In WCDMA, everywhere same frequency. Only change is the spreading ports are the different. But whereas in 4G, 5G, we're using OFDM now, madam. So subcarriers will be different. So whenever customer is moving from one subcarrier to the subcarrier means the break should be there before making a new connection. So all are hard handovers only. And from 5G, hard handovers only.
Sir, what is meant by break before make?
For example, let's say two cells are there. Cell 1, cell 2. Means coverage area. Cell, what is cell means? The geographical area covered by one antenna is called a cell. So a customer is moving from one cell to other cell means while talking or while having a data session is moving from one area to other area means the handout should take place. So break means, suppose if it's a FDMA, cell 1 is having, let's say, one frequency F1. Cell 2 will be having F2 frequency. So when the customer is moving from cell 1 to cell 2, his mobile phone has to tune from F1 to F2 frequency. So oscillator has to tune to the F1 to F2. So F1 to F2 means, so he has to break the F1 frequency before making the F2 frequency, because you will be having one oscillator.
Sir, this concept we can call as a frequency reuse?
Frequency reuse will be done at a distance, madam. We will not be using at a handover is different, frequency is different, because frequency reuse is done only for the purpose of increasing the capacity, because the number of frequencies are less, more supply is less, demand is more, so frequency reuse. Handoff purpose is normally handoff will be done between the neighboring cells only, no? So handoff means you have to break the old connection, means break the frequency of the mobile phone, though it is so refined, so advanced, will be having only one oscillator only. If you are having multiple oscillators, the problem will be weight will be more consumption. So to avoid it, you will be having only one oscillator will be there. So at one moment of time, the mobile phone will be tuned to one frequency only.
Sir, one more question. If the antenna sectors are more, number of sectors are more, what about the power consumption, sir?
Power consumption will be obviously number of sectors means more power means more, when you are taking at the net power consumption of the base station means more the number of sectors, more the number of physical hardware devices will be there, more power will be there, madam.
Sir, one of the participants asked the question, what is the reason behind that the hill area only BSNL network connected rather than other service?
Yeah, I'm sorry, I could not see the chat box. I'm reading it. What's the reason behind that in the hills area only? This is only the policy matter, madam. Policy, as you know, the government's policy is there, and it's a commercially not viable, no, madam. For example, a private operator, he will be going for a hilly area means there will be density will be very less. Low density means low commerciality, low returns will be there, so you cannot go it. So as I told you, in Hyderabad, around 8,000 4G base stations are required. BSNL, no, what we'll be having on less than, we'll be having 50% of that base stations in Hyderabad, whereas we have to divert some base stations in the hilly areas. If you go to Manali, or if you go to any Ooty, or if you go to Coorg, you will be finding BSNL, because it's as per the governmental regulations.
Participant, dear participant, any other
one more question, sir. How the call will be maintained without dropping during the handoff when the frequency is changing?
That's the reason. Actually, the call will be having some buffer. Actually, the handover duration, that should be done within the millisecond. That should happen between in a less than around 5 milliseconds. Because our ears cannot perceive that small duration of time, madam. Actually, there will be break of frequency, but our ears cannot sense it.
Okay, sir. Thank you. Thank you very much, sir.
Sir, I had a doubt. When we use millimeter wave communication, millimeter frequency ranges, how we can increase the device connectivity? Means massive machine connectivity can be improved with the help of millimeter wave. How it is possible?
With the help of machine, MM wave, as I told you, madam, MM wave can be used, but it's not the purpose, because we are wasting MM wave resource only. For implementing the MMTC application, for implementing MMTC is nothing but IoT. There the requirement is large devices are required. Large number of devices will be there. You need to give the connectivity to the large number of devices. For example, in the example what I told you is 1 lakh device will be there in square kilometer. So such a large number of devices, MM wave is not required. You need a low band or mid band is sufficient, madam. MM wave specifically, because MM wave is very costly, no? Operators to get it FR2, they have to pay thousands of crores. I think you might have seen the media. So they don't use it. They use it only for the enhanced mobile broadband, or the people, as I told you, the
low latency.
The low latency applications. And currently, people are working. Many startups are working, and how to take it commercially to the users, to make it commercially more viable. So that is a major challenge currently present, ma'am.
Okay, sir. Thank you.
Yeah, well. Any other doubts, sir?
Sir, good evening, sir. Sir, hello, am I audible?
Yeah, audible, sir. Audible, please.
Yeah, how it is effects on that near far effects on that 5G network, sir? Can you explain?
It will be same, sir. Even if you take a 2G or 3G or 4G or 5G, even at any communication, irrespective of the technology, near far effect is will be there. It will be there. That's a problem. So but in 5G, you're having much more refined techniques are there. So when the customers are very near, so they require less power to be transmitted. When the customers are far away, they need higher power to be transmitted. So this near far effect is taken care much better way. Means how it is taken care much better way means here having in 5G it will be having much better signaling channel mechanism is there. Signaling channels are the one which will be acting behind the mainstream bearer communication. More signaling channels are engaged for the purpose of that detecting the user activity. So we'll be calling it as user activity detection, UAD. At UAD, depending on the UAD detection and depending on the location of the user, the service will be given.
Okay, sir. Right.
Yeah.
Sir,
how is the research is going on this one, sir? Can you elaborate at least on the near far field?
Pardon, sir? Near
far, what is that research? How we can do it on that research on that particular area? How we can improvise that in that 5G or 6G network? What are that solutions we can give it, sir?
Yeah, mainly near far. You are talking about NFC, sir, or you are talking about near far effect?
Near far effect, sir.
Near far effect. So the solution means, see, for research always there will be a scope, sir, because further improvement will be there. currently whatever that is signaling channels are there, they currently in 5G the time slot size is 1 millisecond. 1 millisecond is the time slot size, and the resources are given to the user in 0.5 maximum. The lowest resource that is possible is 0.5. It is half time slot. In half time slot, that possibility is there. So half time slot means 0.5 millisecond. So customers will be given, the users will be given a resource called as PRB. PRB means physical resource block. PRB is a combination of 12 subcarriers. 12 subcarriers means 12 into 15 kilohertz is a 180 kilohertz size will be there. Now the challenge will be in 12 subcarrier size, one PRB having around 104 resource elements. Sir. In resource elements, we will be calling it as resource mapping, or we will be calling it as resource utilization. So each and every resource element will be having some signaling programming will be there. So now what is the challenge is how the resource element are utilized. Currently, whatever 5G is able to do is the resource elements, each and every resource elements will be given some functionality will be there. So we need to find a technique, because every time there will be possibility of improvisation will be there. So we need to find out a different trial and error method. You need to find a different combination of that allocation of signaling channels to the resource grid. And to find out if it can reduce the near far effect. What's the advantage of near far effect means, if you what is the ultimate effect? The battery usage will be much better. Maybe the battery consumption will be reduced.
Yes, sir. Yes, sir.
So that we can do it, sir. That we can do it. So the answer to your one-line answer is better resource mapping. Better resource mapping can be done.
Okay, sir. Thank you, sir. Thank you so much.
Well.
Sir, what about fading, sir? Is it more in 4G or 5G, sir?
Obviously, 5G FR2, if you take FR2, whatever mmWave we are talking about, madam, obviously more fading will be there. All attenuation factor will be much more will be there, because the wavelength is very small. So when the wavelength is small, all the obstacles, 5G are mostly purpose is to use in urban area. In rural areas, 5G, there will be no takers will be there. If you take in hilly area, there is no purpose. Definitely, it will not be there. Only 4G is sufficient for that. And in urban areas only, metros, urban areas, the towns, only district headquarters, 5G will be coming into picture. In the 5G, and if fading will be much more if you're using FR2 band. FR1 is fine, madam. FR2 band, all the obstacles will be there, buildings will be there naturally. That's a big challenge. How they are, how it will be overcome means we need to do better optimization techniques. Sectorization should be much better, and the planning should be much better. And to overcome it, dynamically optimization is they are doing by using AI and ML techniques. They are using it. The antenna azimuth or antenna orientation, the antenna tilt also automatically dynamically varied to overcome this fading, to reduce the fading effects.
What about the Doppler effect, sir? Is it more in 5G compared to 4G?
Yeah, definitely. All the light phenomena effects are much more in 5G, madam. So 5G gets subjected to all these challenge, Doppler effect or the reflection, diffraction, or refraction. Everything is much higher when you're going for higher frequencies. And 5G, as I told you, it is using the carrier frequency also can use up to 800 megahertz or more than 100 megahertz. So that is having, and these frequencies will be available only when you are using a higher frequency band. So that challenge will be there. And to overcome that challenge, as I told you, only SON is the only availability, madam.
Okay, thank you, sir.
Welcome.
Sir, one more query.
Madam.
You said just now, if the number of sectors are more, the power consumption is also more. How to reduce that, sir?
Sectors, I mean to say power consumption means power consumption not in the radio interface, power consumption in the total power consumption. Suppose, for example, we'll be seeing the power consumption in two areas. I think you are talking about radio power. I'm talking about electric power that is consumed. So, for example, you are having three sectors, madam. Three sectors means obviously three hardwares, three different hardwares will be there. Base will be calling it as baseband unit in the base station. So to make it function, the baseband unit, you need to have this power supply should be there. Power supply cards will be there. We will be giving 20 amperes of supply, maybe 50 volts, 48 volts will be given. So the power consumption will be there. To reduce that power consumption also, currently what is the one of the architecture that has came is split architecture. In 5G we are using split architecture. In split architecture, madam, at the baseband unit, we are not using the radio frequencies. The radio frequencies are given at the modulators will be there, right at the antenna only. In the baseband unit only, you will be having the baseband only IF functionality, IF frequency is used. IF to RF conversion will be done at the modulators only. Modulators which will be kept, we are co-located at the antennas. And if you look at the towers, madam, you see to overcome this your whatever the power issue, you can find out at the antennas at the and nearby besides antennas only one box will be there. You might have observed. Those boxes are called as outdoor units, are called as radio remote radio units, RRUs. These RRUs are nothing but the modulators which will convert the intermediate frequency to radio frequency. And other important technologies used to reduce the power consumption is the baseband unit, which is kept inside the building, and the antennas are connected by optical fiber. Optical fibers are used to connect the indoor unit to the outdoor unit. And RF cables are waveguides. Suppose if you're using MM waves, waveguides are used. Waveguides are used only for 1 meter only. That from RRU to the antenna. So when you're using less waveguide, almost waveguides consume more power because it's a copper only. So that's another the advancement that's happening, madam.
Okay. Dear participants, any more queries?
Sir, in future, can we have standalone 5G?
I already Jio are claiming, madam. Jio publicly claiming that they are going for an SIA only. But as far as BSNL is concerned, also it will be done. But because why suddenly government will not convert all the existing NSA to SA means the whatever infrastructure is we have currently we are using the one madam has asked overlaying underlying concept. So we are using the 2G as well, 3G as well, 4G as well. On top of it, 5G is also using. So depending on the customer, dynamically that customer will be brought from 4G to 2G or 4G to 3G to because even the 2G networks are working. So India, what is the Indian context? You know, the completely leveraging the old technology also. So going to complete standalone mode, seamless standalone mode. Jio, they are claiming they're shifting to that one, madam. But other operators, it will take time, madam. Maybe 6G will come by the time.
Okay, sir. Sir, can we get your contact?
Yes, madam. I will share the group.
Okay, sir.
I will share the group, madam.
Okay, thank you, sir.
Welcome. Any other doubt you can ask me, and I'm thank you to. I want to thank our Varishri madam and all the other faculties because they are showing so much interest at this hour. Also, I'm thank you for the very active participation, and I also thank Samskruti College as well as Varishri madam once again.
Thank you so much. Your section is very absolutely highlight for this FDP program, sir. You are spending, yes.
Actually, as I told you, I have shifted to right now in Bangalore. No,
yes,
so I could not participate from Hyderabad.
Okay, sir. And sincerely, I'm thanks to your this thing, sir. Lecture, sir.
Always pleasure.
And you are spending more time with us. Dedication, and I'm appreciating your dedication and inspiring talk. Will be very useful for our future academic profession, sir.
Thank you. Thank you.
You have gained many things. Thank you so much, sir. Thank you so much.
Thank you, man. Thank you. Thank you. Thank you.
Good night, sir. Good night, sir.
Good night. Good night. Good night.
Good night, sir. Sir, you have one more section also on
Yeah,
AIDS.
definitely. I will participate. I will participate.
Okay, sir. Thank you, sir.
Welcome. Good night.
Dear participant, thank you. Good night, all of you.
All participants, good night. Tomorrow, the third day of the session will be there, third day of the FDP. At 6 p.m. It will start. I request you all to join before that. Good night for today.
Dear participant, good night and good day. Thank you.